Hello my dear students, welcome to IMS Gate Academy Gate Score Booster series of Network Theory subject. So this particular subject is common for three branches, EC, Electrical and Instrumentation, and this is one of the most important and basic subject as for gate exam point of view. And in the gate exam, if you're good at network theory subject, definitely you can solve the questions regarding network theory subject. And not only that, if you are good at network theory subject, it is directly or indirectly helping in your core subjects like analog circuit subject or power electronics, etc. In most of the core subjects of EC, electrical, instrumentation, you can easily solve with the help of network theory concepts, right? Even in the EDC subject also, right? So all of you kindly share this video link with all of your friends so that they also will attend this session in live and they also will get benefited from this particular session. In this particular session, I will discuss variety of interesting questions related to the first two chapters of network theory subject. So the first chapter is basics of network theory subject and the second chapter is network theorems, right? So in this particular session, we are going to discuss the variety of questions regarding first and second chapters, whereas regarding the remaining chapters questions I will discuss on tomorrow's session, right? So I hope the agenda of today's session and tomorrow's session, it is clear for all of you, right? So all of you quickly share this video link with all of your friends, right? Okay, so I hope all of you are eagerly waiting for the session. So let us start the session. So this is the first question, and this question is of MSQ type. So that means either one option or more than one option can be correct, right? So you have to verify each and every option whether it is really correct or not. Okay. So all of you give a try. For every question I will give some time. Okay, all of you can try the question, and after solving the question, whatever the options you feel correct, you can mention in the chart. In this particular question, you are having current sources, voltage source is there, and resistors are there. And here in options you are having, in option A you are having regarding voltage across this particular resistor, whereas in option B, option C, option D, they have mentioned the terminology regarding power absorption or power delivered, right? So you have to observe among the sources which are really delivering the power, which are absorbing the power, etc. After that, you can choose the correct options. If you are able to find out among the given choices, whichever are correct, you can mention. Otherwise, at least whichever options you feel wrong, you can mention the option name and you can mention like incorrect. Okay. At least out of 4 choices, each of you try like whichever option you are verifying, whether it is correct or not, you can mention. So whenever MSQ question is there, you are having one question or you are having one circuit, but you are solving like 4 times, right? Because it is MSQ. You have to verify each and every option whether it is really correct or not. Whereas if the question is MCQ, definitely one option will be correct. So the moment you got one of the given choices correct, you don't need to verify the other options whether they are really correct or not. Okay, right? So that's why you have to be patient while you are solving the questions regarding MSQ. Don't be in hurry while choosing the correct options. Okay, you have to verify each and every option whether it is really correct or not. Yeah, time up. So whoever tried, okay, you can mention whichever options you feel correct, okay, or whichever options you feel incorrect, you can mention the chart. So in this particular question, they have given one circuit diagram. In this circuit diagram, you're having two current sources like 0.4 ampere, 0.25 ampere, and one voltage source is there, 6 volt. And after that, you're having resistors, right? And if you observe the choices, okay, option A, they have mentioned regarding VA. That means the voltage across this particular resistor. Voltage across this 100 ohm resistor, they have mentioned as VA. Regarding that, they have given the voltage value as minus 15. Okay. And regarding option B, option C, option D, if you observe, option B, they have mentioned that all the three sources will deliver the power. Here you're having three sources, all the three sources will deliver the power. Option C, they have mentioned, option C, it is mentioned that your whatever the two current sources here you're having, only those two current sources will deliver the power. Whereas in option D, it is mentioned that the voltage source and all the resistors will absorb the power. Yeah, Manoj. Yeah, you might have done some silly mistake. Okay. Right. Because of that, you are given the wrong answer. Okay. So for this question, okay, I will disclose which options are correct in some time. Okay. So first of all, let us verify. Option by option. Okay. So first of all, if in option A, if you observe, they are asking regarding the voltage across 100 ohm. Okay. Whether it is correct or not, now let us verify. Now, just by observing the circuit diagram, okay, whenever you are solving the network theory questions, first of all, you should observe the circuit diagram. What are the given sources or what are the given parameters in terms of current and voltage? Just observe. If you are observing the circuit, then you will get the clue from where you can start or which basic law we can apply or which basic theorem we can apply, etc. Right? So, for this question, if you observe, in this particular branch, already 0.4 ampere current is flowing. Yes or no? 0.4 ampere current is flowing like this. Right? Okay. So that means to this particular node, in this branch, 0.4 ampere current is entering. Right? And in this particular branch, already they have given the current source. Right? 0.25 ampere is current flowing in this particular branch. 0.25 ampere current is flowing in this branch. Now you can apply simply KCL at this particular node. That's all, right? You can apply KCL at this particular node. Here 0.4 ampere is entering, out of which 0.25 ampere is leaving, right? Now, can you tell how much current is leaving in this branch? Sum of all the entering currents should be equal to sum of leaving currents, right? Sum of entering currents should be equal to sum of leaving currents just by observation. Okay, here 0.4 ampere is entering, out of which 0.25 ampere is leaving here. Obviously, the current should leave in this particular branch from this particular node. Okay, so can you guess how much current is flowing like this? It is very simple. Manoj and other students, please mention how much current is flowing in this particular branch. Yes, if 0.25 ampere is flowing like this, that means here 0.15 ampere is leaving. 0.15 ampere is leaving. So 0.15 plus 0.25, how much? 0.4 ampere. So if 0.4 ampere is entering, together 0.4 ampere should leave. That's all. Okay. Now, in this particular branch, you know how much current is flowing? Yes, very good, Ritin. Very good. In this branch, 0.15 ampere is flowing. You know the current flowing and you know the resistor. You know the resistance value, right? Yes, very good, Manoj. Very good. Once if you know the current and once if you know the resistance value, by using Ohm's law, you can calculate the voltage across this particular resistor. Yeah, Ritin, it won't be negative, right? See, you can observe here, 0.4 ampere is entering to this particular node. 0.4 ampere is entering, out of which 0.25 is leaving. See, 0.4 you can write as 0.40. Yes or no? 0.4 you can write as 0.40. Right? Then 0.25 plus 0.15 you will get 0.40. Clear, Ritin? Yes. Yeah. So by using Ohm's law, here you will get 0.15 into 100. 0.15 into 100, that is nothing but 15 volts. 15 volts you are getting. But here they have mentioned minus 15 volts. Minus 15 volts, right? Yes, very good, Manoj. Very good. So that is the reason we have to eliminate option A. Option A is not correct. Okay, some of you might have chosen option A because in hurry you might not notice here minus sign. But here I have intentionally given minus sign. And that option I intentionally have given as option A because most of the students during the exam time also in hurry they will not focus this minus sign, right? So you have to careful whenever signs are there. Okay, right. Yes, very good, Raghutama. Yes, very good. So as of now, with this understanding, option A we have eliminated. Now just observe here. You are having 6 volt source here. And in this branch, 0.15 ampere current is flowing like this. 0.15 ampere current is flowing like this. Now all of you please respond whether this particular voltage source is delivering the power or absorbing the power. This is the most interesting thing. Whether 6 volt source is delivering the power or absorbing the power. All of you can respond whatever you feel, whether it is deliver or absorb, based on your knowledge you can express. Okay. So here during the live session, even though sometime you may do mistake, so don't worry at all. Because if you are doing, due to any reason, if you are doing mistake, no problem at all, because you are getting opportunity to learn something new, right? You can correct whatever the mistakes you are doing, you can correct it. You are getting opportunity, right? Yeah, don't hesitate. Yes, very good, Ritin, Manoj, Raghutama. Yes, fantastic. All of you are giving correct answer, right? So here, just like whenever you are having resistor, okay, whenever you are having resistor or any passive element, okay, always current, just like water, okay, water always will flow from high level to the low level, right? In the similar way. Yes, very good, Kumar. Yes, very good. Similarly, in all the passive elements, okay, in general, the current will flow from high potential to the low potential, right? So if you are having like that conversion, just like you can observe here, in this particular resistor, current is entering at positive terminal, current enters at positive terminal. Whenever current enters at positive terminal, that means it is absorbing. Instead of that, if the current enters at negative terminal, then we will say it is the delivering, right? Okay, just like if you consider, say for example, water is there, okay, from the sump in the ground floor, okay, from ground floor to the, say for example, overhead tank you're having, okay, if you want to send water from ground floor to the top floor, overhead tank, obviously you will use motor, right? Okay, but generally the water will flow from high level to the low level, right? So like that, if current flows from high potential to the low potential, that means it is absorbing. If you are having in the exactly opposite way, that means it is delivering, right? So in this particular case, you are having 6 volt source. So if you observe the voltage source polarity, the current enters at positive terminal. So that means it is absorbing. Right? So as of now, you come to know that here 6 volt source is absorbing the power. 6 volt source is absorbing the power. This is a very interesting thing. 6 volt source is absorbing the power. Now with this understanding, can we eliminate option B or not? Because in option B, here total you're having 3 sources. In option B, they have mentioned that all the 3 sources will deliver the power. But as of now, we don't know regarding other 2 sources. But at least we come to know one of the given 3 sources is absorbing the power. With this understanding, can we eliminate option B or not? Yes, obviously we can eliminate option B. Okay, so as of now, among the given 4 choices, we can eliminate option A and option B. Okay, whether option C and option D really correct or not, now let us verify. Okay, right. So here regarding option C and option D, yes, very good Kumar, very good. Okay, regarding option C and option D, suppose if option C is correct, then directly you can choose option D is also correct. Because in option C, what they have mentioned, only the 2 current sources will deliver the power. Suppose somehow there, if you are able to got that these 2 current sources are delivering the power, that means as of now we got 6 volt sources absorbing the power, and in this given circuit, other than these sources remaining, all are resistors, right? Definitely resistors always will absorb the power, right? Suppose if you are coming to the conclusion regarding option C, if at all it is correct, definitely you can choose option D as correct, right? Okay, now let us verify among option C and option D whether both are correct or not. The moment if option C is correct, you can directly say that option D is also correct. Okay, and in fact, this is the MSQ question. For MSQ question, either one option can be correct or more than one option can be correct. As of now, out of 4 choices, we have eliminated 2 choices. Okay, out of 4 choices, we have eliminated 2 choices. At least one option should be correct, or at least one option can be correct for MSQ question, right? For MSQ, at least one option can be correct just by observing the sentence framing without solving. Say for example, up to here, since if you are able to solve with this understanding, directly you can choose option C and option D. Option C, option D, both are correct. Okay, but now let us see whether option C is correct or not. Okay, right? Now let us verify whether option C is really correct or not. I hope all of you are getting the clarity how I have given the conclusion. See, whenever you are solving any question, definitely after solving the question completely only, you can choose the correct options. But in some questions, they will keep some logic. Once if you are able to identify that logic, okay, even if you are able to solve the question partially, right? And if you are reading the choices carefully, then definitely whenever the lengthy question, sometimes the question seems to be lengthy, but the question sentence framing will be like beautiful. They will keep inherent some logic. Once if you are able to understand the given choices carefully, then even with the help of solving the question partially or half part, you can easily identify the correct options, right? Okay. So for this question, option C, option D, both are correct. But now let us verify regarding option C whether it is really correct or not. So as of now, we got, so whatever the current values we got, I am just representing here. Okay, as per the circuit given. So here in this branch, 0.4 ampere is going. Similarly, in this branch, 0.25 ampere is going. In this branch, 0.15 ampere is leaving, right? And here, if you observe these 2 resistors, they have connected in series. Similarly, these 2 resistors, they have connected in series, right? Series. Okay. So here 225 plus 75. How much you are going to get? I am just representing the equivalent circuit here. $225 plus 75. That is 300 ohm. Then here you are having one resistor and then voltage source. After that, here you are having, sorry, one second. here you're having 300 ohm resistor, and this one is 100 ohm, 6 volt, and then you're having 0.4 ampere current source. I hope it is clear up to this point, right? Similarly here, 125 plus 100, that is 225. 225 ohms. Then here you're having 0.25 ampere. .25 ampere, right? So here we already calculated the voltage earlier. Here you got 15 volt. Here you got 15 volts. Okay. Now if you observe, 0.4 ampere is flowing like this. Now by using Ohm's law, we can calculate the voltage across this particular resistor. So here 0.4, I am writing it as 4 by 10 into 300. So 10 will get cancelled. 4 into 30, that is nothing but 120 volts. 120 volts. Similarly here, 0.25 ampere current is flowing like this, right? 0.25 ampere current is flowing like this. For the time being, 0.25 ampere you can make into, you can represent as 1 by 4 ampere just to do the calculation simpler. Okay. So here you know the current, you know the resistor. Now you can calculate the voltage across this particular resistor. Yes, we can calculate. 225 divided by 4. 225 divided by 4, which is nothing but 4 5s are 20. Then 25 you're having 6 4s are 24. Then 1 is there. So if you're adding 0, then 4 2s are 8. Then 20. Right, 56.25 volts. Okay, right. Now if you observe, here you're having plus 15 voltage and here you're having plus 6 volt. Now together, can you say how much voltage you're having between this node with respect to this node? Here polarities are plus minus, here also plus minus. That means, can we add both the voltages or not? Yes, we can add both. So that means together you are getting plus 21 volts. Plus 21 volts, right? Okay. Now we have to calculate the voltage across this particular current source. Similarly, the voltage across this particular current source. You can apply KVL around this loop, and similarly you can apply KVL around this loop. Yes, very good, Ritin. Very good. Okay. So generally the students will do the KVL or mesh equation here. Okay, you can do. But now I am using that same concept only, but in order to get the answer quickly, I am giving the another approach. Okay. Yes, very good, Raghutama. Very good, Manoj, Ritin. Yes, very good. Now for the time being, if you carefully observe, whatever the representation here I am having, like say for example here, across 300 ohm resistor. Across 300 ohm resistor, you are having 120 volt. 120 volt. The voltage polarities are minus plus, right? And here in this branch, together you are having 21 volts. 21 volts. Now whatever the 21 volts here you are having, for the timing, I am just bringing this entire combination vertically like this. I am placing the entire combination vertical like this. Then polarities will become opposite. So here I am getting minus plus 21 volts. Minus plus 21 volts. Okay. And here you are having 0.4 ampere current source. For the timing, this current source I am placing like this. For the timing, I am placing the current source vertically like this. Then in that case, the 0.4 ampere is flowing like this. See, whatever this loop you are having, instead of writing the mesh equation, I have considered this mesh only. But whatever the voltages here you are having, for easy calculation, I am representing like this. For the timing, I have brought this entire combination to the vertical. Then what will happen? Say for example, this is A, this is B. Then when you are placing like this, B will come like this. That means this minus will come top. Then minus plus 21 volt. Right. After that, this one as it is. Minus plus 120. Minus plus 120. Okay. And then this current source, whatever you're having, for the timing I have placed like this. Okay, then in this branch, if current is flowing like this, when I have kept this same element here, the current is flowing downwards. I hope all of you are getting clarity. Okay, now just observe, here polarities are minus plus, here polarities are minus plus. Now in this case also, just like here plus minus, we have added. In a similar way, here we can add the respective voltages. You are going to get the voltage polarities are minus plus. Okay, 120 plus 21, that means 141. 141 volts you are getting. So that means you are having the current source 0.4 ampere. Now if you carefully observe, the voltage polarities you are getting minus plus. Okay, so you can observe, say for example, here current source direction is like this. That means current is entering where? Minus polarity, and current is leaving from positive polarity. Current is leaving from positive terminal. Okay, just like earlier question. Okay, same circuit. Here if you observe, in this 6 volt source, at positive terminal current enters. That means it is absorbing the power. Now from the positive terminal current is leaving. Or current enters at negative terminal. Both are same. Okay, so that means now can we say that this 0.4 ampere delivers the power? 0.4 ampere current source delivers the power. I hope all of you are getting the clarity. Okay, just by observing the current direction and voltage polarities, we can say whether that particular source is really delivering the power or absorbing the power. Okay, right. Now similarly, let us observe regarding this particular current source whether it is delivering the power or absorbing the power. Okay, so regarding this one, we already calculated that polarities are plus minus 21 volts. So for the timing, I am keeping this branch as it is, voltage. Okay, now for the timing, whatever the voltage here you got, 56.25 volts here across this particular resistor you got, right? Now this particular resistor, for the timing I am placing vertically like this. Okay, when I am placing this resistor vertically like this, then obviously the polarities plus minus will become, here you will get minus, here you will get plus. Okay, now here you got 56.25 volts. Okay, now all of you please respond in this case whether we can add the voltages or whether we have to subtract the voltages. And I am keeping this current source as it is. 0.25 ampere. This is very interesting. Now all of you can respond whether we have to add both the voltages or we have to subtract. Yes, you can observe here. Here the polarities are minus plus, here plus minus. Both are not matching, right? See, if you are having same polarities, then we can add. Okay, if the polarities are opposite, then we have to subtract. Okay, so from which value we have to subtract? It is very simple. Obviously, you can subtract the smaller value from larger. Right? So here, if you observe, obviously this value is larger. So the resultant value you are going to get, you'll get, because this is having minus sign, accordingly you'll get the polarity. Suppose if this is having max value, okay, when compared to this one, then obviously this polarities you'll get like that. Yes, very good, Ritin, Manoj, yes. Now, just by observing the polarities, since both are not same, we have to subtract. Now, regarding the resultant value, whether we have to mention the polarities of this one or this one, just by observing these two values, okay. 56.25 is greater when compared to 21. So that means here you are going to get this polarities here. Okay. So in this case 56.25 minus 21. So that means here you are going to get 6 minus 1 is 5, 5 minus 2 is 3. 35.25 volts you are getting. So the polarities across this particular current source you are getting minus plus here. Minus plus. Okay, just like the earlier case. Current enters at negative terminal or current leaves from positive terminal. Both are same. Right. Yes, very good. So that means 0.25 ampere current source also delivers the power. Delivers the power. Okay. So in this way, whenever in the given circuit, if you are having multiple sources, okay, in general, as the name source implies, it will deliver the power. But in the network or circuit, whenever you are having multiple sources, based on the other network elements present in the network and based on the connections, right? So some of the sources will deliver the power and some of the sources they can absorb the power, right? So this is the conclusion point from this entire discussion. Generally, whoever not having this basic knowledge, okay, fundamental truth regarding the sources, okay, because of that, some of the students in the exam, they can choose option B as the correct. But in some questions, definitely that can be correct. But I'm not saying that, okay. So whenever you're having multiple sources, okay, according to the circuit connections or elements that you have connected, accordingly, all the sources may deliver the power, or some of the sources can deliver the power, some of the sources can absorb the power, right? So this is the most interesting thing. Whoever having that knowledge, okay, after solving the question only, you can choose among the given choices which are really correct, or you can eliminate which are really not correct, okay? So from this entire discussion, whatever in the given circuit you're having, okay, so just by observing whatever I have discussed so far with this in the given circuit, okay, now among these elements, you can easily observe which are delivering and which are absorbing, right? So in this question, the two current sources are delivering the power, whereas the 6-volt source is absorbing the power, and obviously resistors. Whenever resistors are there, obviously they will absorb the power because energy is going to dissipate in the form of heat. Okay, resistor always will take the energy. Okay. Okay, I hope it is clear for everyone, right? So we'll discuss some more questions. Okay, right? Before that, all of you please mention for which year. All of you are targeting for which year GATE exam? All of you please mention. I know that most of you are targeting for the coming GATE exam only, that is 2024. And some of you or maybe your friends or juniors might be targeting for GATE 2025 or 2026, right? So whoever targeting for GATE 2025 or 2026, okay, all of you can share this valuable information with your friends and juniors, right? So here at our IMS Gate Academy, we are starting live online program for GATE 25 and 26 batches. Yeah, very good. Most of you are targeting for 24, right? So all of you can share this valuable information with your friends and juniors, whoever targeting for 2025 and 2026. At our IMS Gate Academy, whoever enrolling for this live online program, they will get the access of 800 plus hours of live classes, right? And here, all our faculties will discuss the concepts from very basic level. Just like in the previous question also, if you observe, we have discussed each and every concept, whether each and every option, whether it is really correct or not. It's not that the moment you got one of the option as correct, okay, we will stop the process. No, not like that. Okay, how or why the other options cannot be correct, we will discuss in detail. Okay, even if any student is having the doubt, we will clarify all the students' doubts during the live classes. Okay, and in addition to the live classes, we will provide the theory books for every subject, and we will provide exercise books, and we will provide 30 plus years GATE question bank, right? So whatever the knowledge the students who are enrolling for our live class program, they will get good command over the concepts and methods of solving. But in order to increase their confidence, okay, we are providing good number of exercise questions. Here in these exercise books, you will be having 3 levels of questions, like level 1, level 2, level 3. You are getting good opportunity to get good command over the subject. Okay, and whatever the basics are there. Say for example, in the earlier question also, some students with the help, whatever the minimum knowledge they might be having, because of that, they can do the silly mistake. Okay, no problem. While they are practicing these exercise book questions, initially they may do some silly mistake, but later they are getting opportunity to become stronger on the basics, and they can overcome how to avoid the silly mistakes, etc. Right? So here we are providing very quality questions in our exercise book, and The specialty of our GATE question bank is wherever possible we are providing for the questions, we are providing more than one solution. Okay, and okay, so if you are go through those alternate solutions, you are getting deeper understanding about the question and how we can solve the same question in multiple ways. Okay, so and in addition to that, we are providing online tests. So together you are having 130 plus online tests. So for every chapter you will be having one chapter test, and for every subject we are providing basic level test and then advanced level test. After that we are conducting, say for example, signals and communication, those are linked subjects. Signals and controls, those are linked subjects. Networks and analog, those are linked subjects. EDC analog, those are linked subjects, like that. Okay, you are having basic subject and advanced subject, right? So similarly we are having, regarding subject test, we are having multi-subject test, right? There we will frame the, you will be having the questions, the concepts based on two different subjects, right? Okay, after that we are having all India mock tests, okay? So together you are having 130 plus online tests. If you are attempting these tests, you are getting good command over the subject, and not only that, you are getting the opportunity to solve the questions in less time. Okay, so you are getting lot of opportunity. And in fact, in addition to all these features, in our IMS Gate Academy, we are providing unique feature, that is My Plan sessions. So for every student whoever enrolled for this program, they will get 12 My Plan sessions. In every month, they can book one My Plan slot with the corresponding mentor, and they can get the proper guidance and study plan. And whatever the challenges they might be facing, they can discuss with the mentor. These are the sessions will happen in the Google Meet half-an-hour slots. Right? Whoever interested for enrolling for this program and whoever having the inquiries or any doubts, okay, regarding this particular program, they can book the free counseling session regarding this particular link. It is already provided in the description of this particular video link. Okay, so all of you whoever interested for GATE 25 and 26 program, they can book the free counseling session. And if at all, if you are having any doubts regarding fees or any particular program features or any other inquiries, you can book the slot and you can get the proper, okay, whatever the doubts you're having, you can get clarified. And in fact, you can call to these numbers. Okay, so all of you kindly share this valuable information with all your friends and juniors, whoever targeting for GATE 25 and 26. Okay, I hope all of you can share this valuable information, right? So this is our Telegram channel, IMS Gate Academy. So all of you join our Telegram channel. It is free for everyone, right? So regarding this particular link also, it is provided in the description. Whoever joining this particular Telegram group, what are the benefits that you are going to get? Okay. So currently we are discussing GATE score booster session in our YouTube channel. It is free for everyone, right? So like this, whatever the upcoming YouTube live sessions are there, right? So all those live lectures updates we will share in this particular Telegram app, right? And whatever the lecture we are discussing currently, whatever I am explaining, not only me, similarly other faculties, okay? During the live lectures, whatever the faculties here, they're writing on the digital board, this soft copy we are providing in the PDF format. Okay, we will share that PDF the moment after the lecture getting over. In this particular Telegram app we will share. And not only that, you will get the notification or updates regarding whenever seminars or webinars we are conducting related to career opportunities, right? And you will get the job notification regarding PSUs and other government job notifications, etc. And not the least, on daily basis, we will provide one quiz question, okay, from one subject. Okay, on daily basis, we will post one question from one subject. Okay, so today we may post one subject question, tomorrow another subject question, like that. Whatever the branch as per, okay. So EC, electrical, instrumentation, computer science, mechanical, civil, okay, data science and artificial intelligence, right? Whoever branch you may be, okay, you can join our Telegram group. On daily basis, you are getting one quiz question. Okay, so that means you are getting the opportunity to learn one new question or solving one question. Okay, after that you can attempt whichever option you feel correct, you can mention, and the very next day our faculties will provide the solution for that quiz question. In this way, you will come to know whatever the knowledge you are getting or whatever the concepts you are learning. Okay, you can check your confidence level and you can increase further. Okay, right. So this Telegram channel is free for everyone. So anyone can join our channel. So all of you please join whenever you get time, and please share this valuable information also with all of your friends and juniors, right? Yeah, this is the next question. This is also MSQ. So I have kept very interesting questions, and I have framed the questions, some of the questions MSQ, some of the questions NIT. So to keep, so that you will get, with the help of one question, you are getting the opportunity to learn multiple concepts or methods of solving. That is the reason intentionally I have framed the questions into MSQ. Right, so in this particular question, you are having one circuit diagram, okay, and here, if you observe, you're having current sources, you're having voltage source, you're having resistors, and here one element is there. We don't know whether it is resistor or voltage source or current source. Okay. So regarding this particular unknown element, you have to identify the correct options. Okay. Here two options it is mentioned regarding absorbing power, two options it is mentioned regarding delivery. How much power delivered across that particular element. So all of you give it a try. All of you give it a try. It is a very interesting question. Just apply the basic concepts. Yeah, as of now, one student has mentioned the answer. Okay, even other students also can answer. Still, we are having some more time. After that, I will disclose. Okay, which options are really correct. For the timing, I'm keeping suspense. Okay, just have some curiosity whether your options are really correct or not. Yeah, time up. Whoever's still trying. Okay, after solving the question, what are the options you are feeling correct, you can mention the chart. Okay, for the timing, I'm keeping suspense. Okay, what are the options you have mentioned, whether it is really correct or not, I'm keeping some suspense. Okay. Right. So in this particular question, you're having current source, voltage source, current sources are there, and here two resistors are there, and they have given one element. Okay, here in this particular element, you are having current flowing through this particular element is I, and the voltage across it is V. Okay, so regarding this particular element, they have mentioned two choices regarding absorbing power, two choices they have mentioned regarding delivered power. Okay, right. So if you carefully observe, see whether we have to apply KCL or KVL, nodal, mesh, you will get the clue. Okay, so just by observing the circuit carefully, okay, you will get the clue from which point you can start. Okay, say for example, for this particular circuit, either you can consider this particular point, or otherwise you can consider this particular point. Okay, you can consider this particular point, or otherwise you can consider this particular point. With the help of any one point, at any one point, you are getting the clue. Yes, very good, Raghutama, Manoj. Yes, very good. Okay, so here if you observe, in this particular branch, 5 ampere is going, and in this particular branch also 4 ampere is going, right? Say for example, if you are considering from this particular node, okay, so in this branch 5 ampere is going like this, and similarly in this branch 4 ampere current is going like this. That means from this node, in these two branches together 9 ampere current is going, or 9 ampere current is leaving from this particular node together. That means here in this branch, okay, 9 ampere current should enter. Okay, I hope all of you are getting clarity. Suppose if 9 ampere current enters like this, then together 5 plus 4 is 9 ampere is leaving. That's all. Yes, very good, VKM. Okay, yeah, thank you. So in this particular branch, 9 ampere current is flowing. So that means as of now we got the current flowing in this particular branch. Okay, so somehow or other, if you are able to calculate voltage across this particular branch, so once if you know current, once if you know voltage, we can calculate the power, and based on that power value, we can tell whether this particular element really absorbs the power or delivering the power. Okay, right. So in order to find out regarding this particular voltage, let us observe here. In this particular branch, already they have given 10 volt source. That means you know the voltage across this particular branch. Okay, somehow or other, if you know the voltage across this particular branch and voltage across this particular branch, then we can apply KVL around this particular loop, right? Okay. Now, here if you observe, just like here, at this particular node, 9 ampere current is entering, and together 9 ampere is leaving. Now with this understanding, in this branch 5 ampere is entering, here 4 ampere is entering, together 9 ampere is entering, so that means 9 ampere should leave. That's all. Okay, I hope all of you are getting clarity. From this node, 9 ampere is leaving like this. Okay, see, forget about this entire network. If 9 ampere is, if you are considering this like 2-port network, okay, if current 9 ampere is entering like this in this terminal, the 9 ampere should leave from another terminal. Okay, I hope all of you are getting clarity. Okay, now at this particular node, 9 ampere current is entering in this branch, and 3 ampere current is entering in this branch. So at this particular node, in these two branches together 12 ampere is entering. That means 12 ampere should leave. Okay, now by using Ohm's law, you are having 12 ampere and 2 ohm. That means 24 volts you are getting. And these two are in parallel. In parallel, voltage will be same, right? Okay. Now just consider this particular node. Here 12 ampere is entering, and in this branch 3 ampere is leaving. 12 ampere is entering, out of which 3 ampere is leaving. So that means 9 ampere should leave. Or in other words, in simple words, okay, just observe, just consider this entire thing as a single network. Okay, for this network, if I am sending 9 ampere current like this, obviously from the overall network 9 ampere should leave. That's all. Okay, just like here, 9 ampere if enters here, 9 ampere should leave. In the similar way, for this overall network, if 9 ampere is entering, 9 ampere should leave. Correct? Okay. Now Here once again apply KCL at this particular node. 9 ampere is entering, out of which 3 ampere is leaving. Okay. Here you have to carefully observe. Here 9 ampere is entering and 3 ampere is leaving. Sorry, 9 ampere is entering, out of which 2 ampere is leaving. Correct? 2 ampere is leaving. So that means in this particular branch, 7 ampere will leave. I am repeating once again, 9 ampere current is entering, out of which 2 ampere is leaving. Here 2 ampere is leaving. So 9 minus 2 is 7 ampere. 7 ampere. Now by using Ohm's law, 7 ampere into 3 ohm, you will get 21 volts. You will get 21 volts. Okay. See, now you are considering one closed path. In this closed path, you know the voltage across here, you know the voltage across here, you know the voltage across here. Obviously, you can find the one unknown voltage. Yes, Raju, I will discuss that method also. Okay, first I am discussing regular method. After this, I will discuss that method also. Okay. Yes, you are right. I will discuss that method also. Okay, right. So, for the time being, here if you observe carefully, here you are having, instead of writing mesh equation or KVL, just like in the earlier question, same approach I am giving here. Okay, here you are having plus minus 21 volt. So here I am having plus minus 21 volt. I kept as it is. Next. Here I am having plus minus 24. This branch I have kept like this. Okay, the moment you are keeping the branch like this, here you will get plus minus 24 volts. 24 volts. Right. And then here you are having 10 volt source. Here the polarities are plus minus. Okay. Now if you are bringing this one vertical I am keeping, then you will get polarities in the opposite way. Right. So minus plus you will get. Minus plus you will get. Okay, I hope all of you are getting clarity. Here plus minus, so minus will come top. Now if you carefully observe, these two you are having plus minus, so we can add. Okay, plus minus we can add. So that means here you are getting 24 plus 21. So 25 plus 20, 45. Okay, here you are having minus plus 10 volt. So now just observe, here polarities are minus plus, here plus minus. That means which polarities you will get? Whichever is larger, that polarities you can consider. Here larger value is plus. So 45 minus 10, that is 35 volts. 35 volts. You are getting polarities are plus minus. Okay, right. Now, up to now what we have done, whatever these two elements we are having, we have kept vertically this side. So together we are getting voltage 45 minus 10, together we are getting 35 volts. Okay. Now whatever this branch is there, now you can keep vertical like this. Then here you are having the element like this. You are having the element like this. Okay. And the moment when you have kept this element like this, okay, current is entering like this, right? Current is entering like this. Okay. Now just observe. Here you got voltage polarities plus minus 35 volts. 35 volts you got. Now just observe. Current enters at negative terminal or current leaves from positive terminal. Both are same. Whenever current enters at negative terminal, obviously it is delivering. So that means whatever the given element is there, that actually delivers the power. How much power it is going to deliver? Whatever the voltage you are having, whatever the current you are having. So current value is 9 ampere, voltage value just now we got 35. So 35 into 9. That is nothing but 9 5s are 45. Then 9 3s are 27 plus 4, 31. 315 watts. Okay. So in this way you can calculate or identify whether the given element really absorbs the power or delivers the power. Okay. So the moment you got delivered power as 315, so absorbed power will be how much? minus delivered power. Just like 5 ampere current, if it is flowing like this, in the opposite direction, we can say that minus 5 ampere current. In the similar way, if you are getting that actual the power, if you are getting positive, okay, so in this case 315 watt is the positive value. So just by observing the sign convention, it is actually delivering the power. The moment if delivered power is positive, obviously absorbing power will be negative, vice versa. So that means here you will get minus 315 watt. Minus 315 watt. Okay. Suppose in this question, regarding this particular element, in some question, so after solving this question, actually we got delivered power as 315 watt. Okay. But in some question, they can ask that how much power absorbed by this particular element. If you are getting delivered power is positive, that means absorbed power will be negative. Suppose after calculating the question, after solving the question, suppose really if you are getting absorbing power only positive, then definitely that value will consider. Okay. But actually if the element is absorbing the power, but intentionally they can ask how much power is delivered. Okay. That time you have to put minus sign. Okay. That is the reason here also sometimes students will do silly mistake. Regarding that minus sign, they will ignore. Okay, that is the reason intentionally I kept this question now. Okay, right. So with this understanding, now you can choose the options. Delivered power is 315 watt. Delivered power is 315 and absorbed power is minus 315. So options B and C are correct. Yes, very good, Raghuttama. Excellent. Now for this question, just try to identify among all the given elements, okay, among all the given elements, which elements are delivering the power, just identify, and total how much power delivered by them, calculate. And similarly, identify which elements are absorbing the power and calculate the total power absorbed by them. All of you give it a try. Just by observing this circuit diagram, try to identify among all which elements are absorbing, which elements are delivering, and together whichever elements are absorbing, together how much power you are getting, and similarly whichever elements are really delivering, together how much power you are getting. Yeah, just observe. As of now, we got this unknown element is delivering the power. Okay, just by observing this particular circuit diagram and calculation up to now, we have told that whenever you are getting positive quantity, that means actual that particular whatever notation you have considered, that is true. Okay, the moment you are getting negative, okay, that means it is not. It is a like theoretical concept. Okay, right. So that means here the unknown element actually delivers the power. Okay, as of now we got unknown element. Here which elements are delivering the power? So first I am considering, I am making the tabular form. So here I am mentioning the network element. And here I am writing the corresponding delivered power. Okay, so first I am considering this unknown element. Since we already got it is delivering power. Unknown element. So after doing calculation, we got 315 watts. 315 watts. See, just by observing the voltage polarities and current direction, you can say whether it is delivering or absorbing. Okay, first let us focus regarding deliver. Yes, very good, Raghuttama. Very good. Yeah. So for the time being, let us consider this 4 ampere current source. For the time being, I am considering here 4 ampere current source. Here you are having. Okay. Here 4 ampere current source you are having, and these two are connected in parallel. In parallel, voltage will be same. Voltage will be same. So since you know the voltage source here, so the same voltage here you will be having. Okay. So current leaves from positive terminal or current enters at negative terminal. Both are same. Current enters negative terminal or current leaves from positive terminal. So that means it is delivering the power. It is delivering. Okay, so 4 ampere current source is delivering. 4 ampere current source. 4 ampere current source, it delivers the power. Okay, so you know the voltage, you know the current. You can multiply 10 into 4. 10 into 4, that is 40 watts. 40 watts. Similarly, now let us consider this voltage source. Right. Here voltage source 10 volts. Voltage polarities are same, plus minus, plus minus. And here 5 ampere current already they have given in the circuit, right? So from positive terminal only current is leaving. Just like here, positive terminal, from positive terminal current is leaving. So that means it is a source. It is delivering. So this 10 volt source also delivering the power, right? 10 volt source also delivering the power. So here voltage is 10, current is 5. 10 into 5, that is 50 watt. 50 watt. Now let us focus this 3 ampere current source. 3 ampere current source. Okay. So these two are connected in parallel, same voltage, right? So 3 ampere current source, arrow direction is like this, current direction is like this. Okay. And here if you carefully observe, voltage polarities you are having plus, minus 24. So current leaves from positive terminal, current leaves from positive terminal. So that means it is also source. Just like here, current leaves from positive terminal. Similarly here also current leaves from positive terminal. So it is also delivering the power. Delivering the power. So 3 ampere current source. It is delivering the power, right? So across this 3 ampere current source, we are having 24 volts, 24 volt. So voltage is 24, current is 3. 3 into 24, that is 72 watts. Now with this understanding, all of you tell me, we are having one leftover source that is 2 ampere, whether it is absorbing the power or delivering the power. All of you give it a try. Here you are having 2 ampere current source, right? So I have considered regarding unknown element, I have considered 4 ampere source, I have considered 10 volt source, I have considered this 3 ampere. All these 4 elements, we come to know that all these are delivering, right? What about this 2 ampere source? Whether it is delivering or absorbing. See, it is very simple. How these 2 elements are connected? Parallel. In parallel, same voltage you will be having. So here also you will be having voltage will be same, plus minus, right? So here voltage polarities you are having plus minus. Okay. So in this case, current enters at positive terminal. Current enters at positive terminal. So that means it is what? Passive sign convention. Whenever you are having resistor, current always will flow from high potential to the low potential, right? So that means this current source is actually absorbing the power. Yes, very good, Manoj. Very good. This current source is absorbing the power. So here we are having 2 ampere current source. It is absorbing the power. We are having 2 ampere current and across it voltage is 21 volts, right? 21 volts. 21 into 2, that is 42 volts. 42 watts. Voltage into current, units are power units are watts. Okay. 2 into 21, that is 42 watt. So among all the sources, okay, current sources, we have identified among these 3 current sources, these 2 are delivering and this one is absorbing. And regarding this voltage source, it is delivering. And regarding this element also, it is delivering. Right. And here in this network, okay, other than these sources and this particular unknown element, remaining are simply resistors. Obviously, whenever resistor is there, obviously it will absorb the power, right? So directly you can consider regarding 2 ohm and 3 ohm. Okay, first I am considering regarding 3 ohm resistor and then 2 ohm resistor. So regarding 3 ohm resistor, you are having voltage as 21 and current flowing is 7 ampere, right? Voltage into current, 7 into 21 or 21 into 7. 21 into 7. So 7 1s are 7, 7 2s are 14, 147 watt. Similarly, regarding 2 ohm resistor, you know the current flowing in this branch is 12 ampere and voltage is 24 volts. 24 into 12. 24 into 12. So 12 4s are 48, then 12 2s are 24. You will get 248 watt. Okay, so total in the given network or circuit you are having total 7 elements, out of which 4 elements are delivering the power and 3 elements are absorbing the power. Now let us calculate the respective delivered power total and similarly respect to absorbed power. Okay, so if you are adding all this, okay, then what you will get, 40 plus 50 is 90, 90 plus 3, 315. So that means 405 you will get, 405 plus 72, that means 477 watts you are getting. This is the total delivered power, right? Similarly here, 248 plus 42, 250 plus 40, 290 you are getting, okay. 290 plus 100, 390, 390 plus 40, that means, one second. Sorry, here I have done some calculation mistake, just one second. Here 12 4s are 48, 4 is there, 12 2s are 24 plus 4, 28, 288 watts, sorry. Okay, so here 288 plus 2, 290, 290 plus 40, 330, 330 plus 40, 370, 370 plus 100, 470 plus 7, 477. 477 watt. Okay, so in this way, whether you are calculating in the given network, whatever the elements which are delivering the power, the resultant sum, okay, it is equal to whichever elements actually absorbing the power. Okay, if you are adding the net absorption power, right, so both will match. That is called diligence theorem. Okay, so in any network or circuit, okay, total whichever elements they are delivering the power and whichever elements are absorbing, together if you are considering the net power, okay, how much power is supplied, that much entire power should be distributed or absorbed by the other elements, like that. Okay, so in this way, whatever the earlier conclusion point I have mentioned, whenever you are having multiple sources present in the given circuit, you should not say that directly all the sources will deliver the power. Okay, whether they can deliver the power or some of the sources can absorb the power based on the given network and based on the elements which are connected to it. Okay, so that is the one of the conclusion point and interesting point in this entire from the previous question, this question. Okay, so whenever they are asking any question regarding among the given elements which are delivering, okay, so just by observing the voltage polarities, okay, you can mention whether it is delivering or absorbing. Okay, whenever current leaves from positive terminal, it always deliver. Whenever current enters at positive terminal, it always absorb. That's all. Okay. Okay. Yeah. As Razu asked. Okay. Yeah. Now I am going to discuss another method. Okay. Regarding the first question. Regarding the second question, starting. Regarding the unknown element, we have given 4 choices, right? Regarding the absorption power and deliver power. Regarding this question, I am discussing the second method. So here we are supposed to calculate regarding this particular element how much power delivered or how much power absorbed. Okay. Now here if you observe this part of the circuit, if you observe this part of the circuit, here which technique we can apply? All of you please respond. Similarly, here also, if you observe this part of the circuit, which technique we can apply? Already Razu has mentioned earlier in the chart section, so all other students also can answer. Here you are having what? Current source in parallel to resistor. Similarly here current source in parallel to resistor, right? So we can apply source transformation technique. We can apply source transformation technique. With the help of source transformation technique, we can convert the practical current source into practical voltage source, similarly practical voltage source into practical current source, vice versa. Yes, very good Manoj, very good. So wherever while you are solving the question, okay, wherever you are supposed to find the response, there we cannot apply source transformation, but other than by disturbing that network or part of the circuit, okay, remaining all the places wherever there is a possibility to apply source transformation, and before applying source transformation, just observe one point with the help of source transformation, whether we are able to simplify the network or whether we are increasing the calculation part unnecessarily. Okay, wherever the calculation part becomes simpler, definitely you can apply source transformation, right? Yes, very good. Very good, Manoj, Ritin. Yes, very good. We can apply source transformation here. We can apply source transformation technique here. So here you are having current source in parallel to resistor. This one we can convert into a voltage source in series with resistor, right? So here 2 ampere into 3 ohm. Okay. So regarding this 2 ampere current source, just now we have mentioned whenever we are applying source transformation, that means whatever the source present here, that means already we are assuming that is delivering the power, right? That is the assumption. So if you are considering that is the assumption, so here current enters at positive terminal and current leaves from positive terminal, right? Okay, so now we are having current source in parallel to resistor, that when we are converting into voltage source, generally students will get confusion, sir, whether we have to consider voltage polarities like plus minus or minus plus. Okay, no need of any confusion. It is very simple. Whenever you are having current source or voltage source, always current should enter at negative terminal and current should leave at positive terminal. Okay, any one point you can remember, with the help of one point, obviously the other point is valid, right? So whatever the polarities just now you have got, now you can represent the equivalent circuit accordingly. So 2 into 3, that is nothing but 6 volts, right? And then here this is the practical current source in parallel to resistor. We are converting into a voltage source in series with resistor. So here you are getting 3 ohm. Okay, you can keep resistor here or here, no problem. Ultimately both are connected in series. Okay. Now similarly here, regarding 3 ampere current source. Okay, current source. Okay, so that means here it is negative polarity, here positive polarity, just like here. Current enters at negative terminal and leaves from positive terminal, right? So once again here 2 into 3, that means voltage polarities you will get minus plus. Voltage polarities you will get minus plus, right? 2 into 3, that means 6 volts. Okay, 6 volts, and then in series with 2 ohm. Okay, I hope it is clear up to this point. Now whatever the rest of the circuit you are having, you can draw as it is. Here you are having current source and voltage source, you can keep as it is. And here the unknown element you can keep as it is. Okay, right. So whatever, while solving this question in the earlier method, the first law that which we have applied, same law here also you can apply. The KCL, either you can apply at this node or this node, no problem. So 5 ampere, 4 ampere, both are entering, so that means 9 ampere is going like this. Otherwise, at this particular node, if you observe, 9 ampere current is coming like this, that means together 9 ampere current is like that. Okay. So here the current direction they have mentioned like this in this particular circuit, the same direction. That means current direction, whatever they have given, that value getting positive, so that means we no need to change the current direction. Okay, suppose you got, after calculating like this, if you got the current value negative, that means whatever the current direction they have given, we have to consider opposite way. Actually the current is flowing in the opposite way. But whenever you are getting positive value, that means what is the direction they have given, that is correct. Right. Now, here if you observe this part of the circuit, if you observe regarding these two voltage sources, okay, if you observe regarding these two voltage sources, net voltage value, how much you are going to get? Any guess? Net voltage, how much you are going to get? Okay, just for reference, if you want, I will represent here. Okay, here you are having minus plus 6 volts and here plus minus. This one I am keeping vertical like this. Now can you tell how much voltage you are going to get? Obviously, it is very simple, right? Here plus minus, here minus plus. Obviously, we will do subtraction. So since both are having same magnitude, so that means 6 minus 6, that is equal to 0. 0 volt. Either you can consider plus minus or minus plus, no problem at all. Because 0, plus 0 and minus 0 both are same. So that means this resultant voltage you are going to get simply 0 volt. 0 volt. Okay, if you want, you can consider voltage polarity is plus minus like this or volta, no problem. Because in this case, both are having same magnitude. Okay, now here 2 ohm resistor and 3 ohm resistor, these two are connected in series. 2 ohm, 3 ohm are connected in series. So that means 2 plus 3, you are getting 5 ohm. 2 ohm and 3 ohm, both are connected in series, you are getting 5 ohm resistor. And 9 ampere current is flowing like this. 9 ampere current is flowing like this. So here in this particular branch, 2 ohm plus 3 ohm, together you got 5 ohm, and in that 5 ohm resistor, 9 ampere current is flowing like this. By using Ohm's law, you will get 45 volts. 9 into 5, that is 45 volts. Okay, now if you carefully observe, here, whatever this entire network you are having, for the timing I have considered like single resistor. Okay, and voltage you are having plus minus 45. Okay, whatever you got here, for the timing I am representing here, plus minus 45. Now, here you are getting one closed path. You are getting one closed path. Here you are having 10 volts. The voltage polarities you are having plus minus. Now for the timing, you keep this voltage source. You can keep or you bring this voltage source like this vertical. Then polarities will become opposite. Minus plus you are going to get. Minus plus you are going to get. Okay. Now the resultant voltage. Here just like here plus minus minus plus. Obviously we will do subtraction. And here in this case, positive plus polarity, plus minus, this one is having more value when compared to minus plus. So that means resultant voltage polarities you are going to get plus minus. 45 minus 10, that is nothing but 35. 45 minus 10, that is nothing but 35. 35 volts you are getting. Right. Now whatever this branch you are having, now you keep vertical like this. You keep vertical like this. Right. So if you are keeping that branch element like this, then according to this current direction, same, upward you are going to get current direction I. And now the voltage polarities you got like this. Okay, plus minus you got, that means 35 volt, 35 volt, 35 volts. Okay, so here current value you got 9 ampere. Now you can observe current enters at positive terminal and current leaves from positive terminal. So that means obviously it is delivering. Obviously it is delivering, right? So regarding delivered power, already we calculated, that is 35 into 9, that is nothing but 9 5s are 45, 9 3s are 27 plus 4, 30, 27 plus 4, 31. Alright, so delivered power if it is positive, absorbed power will be negative. Minus delivered power, that is nothing but minus 315. In this way, whenever you are having any network or circuit, Okay, definitely you can solve the given circuit or network in more than one possible method. Okay, wherever possibility is there, you can solve the same circuit or network with the help of more than one method. Okay, so just for understanding, the earlier method I have discussed with the help of simple KCL and KVL, and in this question I have applied the source transformation, right? So whichever method you feel comfortable, okay, and in fact, by following whichever method you can solve the given question in less time, obviously that will be the shortcut method. Okay, so for understanding the concept, initially I will discuss the conventional approach, after that I will discuss the shortcut, and here the main agenda of this GATE score booster session is we are going to revise most of the important concepts, expected concepts for your coming GATE exam through the questions. Okay, so this is one of the best way to revise all the concepts or important concepts through the problem solving, so that you are getting, while you are solving the problem, you are getting the confidence whenever you are getting the correct answer. Suppose due to any reason if you got wrong answer, no problem at all. Here we are discussing the method, so whatever the basic concepts are there, you are getting deeper understanding, and in fact you are getting the clarity about each and every concept, right? Yes. Yes, Ritin. So here, according to the, say for example, here in this particular circuit they have given plus minus, right? Okay, suppose the same polarities you are considering, plus minus V. Okay, so according to that, here you are going to get minus plus, minus plus. Okay, no problem, no problem. So if you are considering like that, so now just observe, here you got actually plus minus, right? But here you are having minus plus, and this plus and minus both are not same. So that means here if you are getting 35 volt, so according to the given question, the voltage across this particular element, that will be minus 35 volts, or in other words, say for example, current enters, if you are considering with respect to the given voltage polarities, current enters where positive terminal. If current enters positive terminal, so that means the element you are considering as absorbing, right? Okay, but here entering current is 9 ampere only, but what about the voltage value? Just by observing these polarities, you are getting V as minus 35 volts. Okay, so when you substitute minus 35 and 9, obviously you will get minus 315. Is it clear, Ritin? This is a very interesting question. That's why I have kept this question as MSQ, and generally students will get confusion. Okay, see, whenever any element, if current enters positive terminals, so obviously by default you can consider absorbing. Okay, but whatever the value you got, if you are getting that absorbed value positive, that means definitely that given element is absorbing only. But the moment you are getting negative, that means actually it is delivering, like that, vice versa. Is it clear, Ritin? Any doubt? Even other students, please respond. Is it clear? If you are having any doubt, you can mention in the chat. Yeah. Yes, very good, Ritin. Very good. So whenever you are getting any doubt, okay, don't hesitate. First you can focus whatever the method I am discussing. First focus on that method or concept. After that, if you are getting any, like whatever you might have solved the same question in the different approach or different method. Okay, wherever you are getting any ambiguity or doubt or stucking, so you can mention your doubt. Okay, at the end of or whenever I am explaining one complete concept. After that, you can ask in the chat. Okay. So don't hesitate. Whatever the doubts you're having, you feel free to ask any doubt. Whatever the questions we are discussing regarding these concepts, if you're having any doubt, you can mention in the chat. I will clarify all of your doubts. Okay? Right. Yeah, this is the NIT question. So obviously answer will be a number. Right. So in this question, I have given a network. In this network, completely you're having resistors. You have to find out the equivalent resistance across these two terminals. When you're looking this overall network with respect to these terminals A and B, then what is the equivalent resistance that you are going to get? All of you give it a try. Yeah, Ritin, you can cross check once. You might have done somewhere mistake. So which method you have followed for doing the simplification of this given network? So which concept you have applied? Other students still we are having time, so meanwhile you can try. Ritin, in order to find the simplified network, which concept you have used regarding the equivalent circuits of resistors? Yeah, time up. Whoever is still trying, okay, after solving this question, whatever the answer you are getting, you can mention in the chart, right? So in this circuit, you are having completely resistors. See, when you look at this circuit diagram, initially you may feel that, sir, it is a very difficult question, or we may have to apply star delta concept, right? Yeah, just like Manoj is mentioning, star delta. See, if you want, you can solve this question with the help of star delta, but definitely it will take more time, right? But before applying star delta, see, not only star delta, any network concept or method, before you are applying, just observe one point. Before applying that concept, whether you are able to solve that question in less time or whether your solving time is getting increased. Okay, so with the help of that one important key point, you will come to know that whether you can apply that method or not at that point of time. Simple. So for this question, here you're having like delta form. If you want, you can convert into star. Later, that star you may convert delta, like that you can solve, but definitely it will take more time. But if you carefully observe this given circuit or network, so in this circuit you're having one here, just observe the node points or connection points. Okay, so just observe here, this is one point, okay, this is one point and this is one more point. Now just observe whether this point and this point both are same or not. See, this point and this point I just connected with the help of simple wire, right? Now the moment if you have observed this one, there is no need of applying star to delta or delta to star in this question. This is the key point, okay, right? So I am repeating once again. Say for example, I am considering this is like here AB points they have mentioned. For the timing I am labeling like this. This is C point, this is D point, then this is, say for example, E point, and this one both are same. So since both are same, I am mentioning like F. Otherwise, if those two are different, you can mention like F and G. Okay. So the moment you have observed that this point and this point both are same, since I have connected with the help of one wire. Now see the beauty here. Now see the beauty. Yes, very good, Manoj. Very good. Same node only. Correct. Now, if you carefully observe, between E and F, with respect to this branch, you are having 160 ohm resistor. Now, you are having one more path like this. Now, in this path, if you observe, this 12 ohm resistor also is connected between same nodes, between E and F only connected, right? So, whatever this connection here you are having, for the time being, okay, for the time being, I am just considering between E and F. Between E and F, we are having two resistors. Can we connect like this? Between E and F, we are having two resistors. One resistor is 60 ohm and other resistor is 12 ohm. See, when I have given the circuit directly like this, all of you can easily visualize that these two are connected in parallel only. But here you are getting one IQ level, right? This is the IQ level question or logical question. Directly they haven't mentioned in the question those two are parallel. But if you are carefully observing, definitely you can visualize that these two are connected in parallel only. That is the beauty of this question. That is the reason in this entire session I kept the logical questions or interesting questions, so that whatever the methods or concepts you have learned, those methods only, whatever the concepts you might have studied regarding network theory subject, the basic concepts only we are applying, but the way of solving or way of observing the given circuit or which law or which method we have to apply, that is the key point, trigger point, right? When to apply which law or where we cannot apply which method or etc. You are getting the opportunity. Okay, so with the help of this gate score booster session, all of you are getting whatever the experience that you are going to get. Definitely I can say whatever today 3 hour session, tomorrow 3 hour session we are going to discuss, definitely it is going to give a great value addition, right? Whatever you might have prepared up to yesterday and just observe today's session and tomorrow's session, definitely whatever the knowledge that you are getting or whatever the method of solving you are getting, definitely it is going to play an impact in your learning regarding network theory subject. Definitely whatever you are learning here, it is going to increase your marks in the network theory subject, and indirectly it is helping to solve the questions of other subjects like analog circuits, EDC, electrical machines, power electronics, etc. Okay, even instrumentation branch, whatever the core subjects you are having, for solving any circuit or network, definitely you will apply the basic methods or theorems, right? Yeah. So now 60 ohm and 12 ohm, these two are connected in parallel. So now we can represent the resistance across E and F terminals, 60 in parallel to 12, 60 in parallel to 12. So that means 60 into 12 divided by 60 plus 12. Directly I am writing 72. So 12 6 are 72, 6 10s are 60. So that means you are going to get this overall resistance. Now you can represent as simply 10 ohm, right? Okay. Now after this, I'm just, instead of drawing the complete circuit or network, I'm just drawing part by part so that you can easily understand. Later, whatever the remaining part required, later I will add. Okay. So for the time being, I'm considering the point C. From point C, you're having 20 ohm resistor. You're having 20 ohm resistor. Between point C and point E. Between point C and point E, you're having 20 ohm. Okay. And between E and F, just now we got equivalent resistance as 10 ohm. Between E and F, we are having, just now we got 10 ohm. Okay. Now, if you observe carefully, between C and F, you are having one more branch, that is 30 ohm resistor. Between C and F, we are having one more resistor, 30 ohm, right? After this, here you are having, just one second, here you are having 10 ohm. Between D and F, you are having 10 ohm, and between C and D, you are having 25 ohm. You are having 25 ohm. Okay, after this you are having 5 ohm. And then here you are having 15 ohm. Okay, I hope it is clear. Whatever the given circuit is there, I have converted into the like this after calculating the equivalent resistance. Now all of you tell me how these two are connected. 20 and 10, how these two are connected. How those two are connected? Series, right? 20 and 10, they are connected in series. So in series, we can add the resistance values. 20 plus 10, that is 30 ohm. Now if you carefully observe, between C and F, in this branch you are having 30 ohm resistor, and you are having one more branch, 30 ohm resistor. And how these two are connected? 30 ohm, they are connected in parallel. 30 ohm connected in parallel with 30 ohm. So that means you are going to get 15 ohm. Yes, very good, Manoj, very good. Okay. So as of now, what we got, between C and F, after doing the simplification, you are getting one resistor, that is 15 ohm. Okay. Now, Now, whatever the part of the circuit here I am having, okay, simplified circuit I am drawing. Here 5 ohm resistor that is present between A and C. Next, here between C and D you are having 25 ohm. Then between B and D you are having 15 ohm. Between B and D 15 ohm. After that, between D and F we are having 10 ohm. Now, between C and F, after doing the entire network, after doing the simplification, okay, we got 15 ohm that I am keeping here. Now tell me how these two resistors are connected. 15 ohm, 10 ohm. These two are connected in series, right? These two are connected in series. So in series we can add the resistors. 15 plus 10, that is 25 ohm. Now if you observe carefully, between C and D, we are having 25 ohm resistor, and in another branch, just now we got 25. Okay, these two are, how they are connected? These two are connected in parallel. Yes, very good. These two are connected in parallel. 25 in parallel to 25. That is 12.5 ohms. 12.5 ohms. So that means here between A and C you are having one resistor, and between C and D just now you got one single resistor, that is 12.5, and between B and D you are having 15. Okay, right. Now we have to calculate the equivalent resistance between A and B. So RAB is nothing but whatever the three resistors finally you got, just you have to add, that's all, because all the three are connected in series, right? 5 ohm plus 12.5 ohm, then 15 ohm, 5 ohm, 12.5 ohm and 15 ohm, all are connected in series, right? Very good Manoj, Ritin. So 5 plus 15, 20, 20 plus 12, that is 32 point, here 0.5 you are having, that one you will get. So the final equivalent resistance across the terminals A and B, that is 32.5. Yes, very good Ritin. Okay, earlier you might have done somewhere mistake, that is the reason you got earlier different answer. Okay, so for this given network or circuit, with the help of simple like series connection, parallel connection, with the help of that method, you can easily calculate the equivalent resistance. Okay, wherever series connection or parallel connection, wherever you are able to identify, if you are facing any difficulty that in a given network it's not possible with the help of series connection or parallel connection, then definitely you can apply star to delta or delta to star according to your requirement, okay, or convenience, whichever method, star to delta, delta to star, as per the convenience you can go ahead. But in whichever cases, wherever you can easily solve the question with the help of series connection or parallel connection, first of all give the priority to that one so that you can solve the question in less time. Okay, definitely if you want later you can give a try, you can solve the same question with the help of star to delta, delta to star. Ultimately you will get the same answer, but definitely that method is going to take more time. Okay, right. Now this is the MSQ question, and this is the one of the most interesting question in this entire session. Like this you will get, okay, more interesting questions, but this is one of the most interesting question. Okay, so all of you give a try. In this question you are having one voltage source is there, one current source is there. Regarding these two I haven't mentioned. Regarding those two, regarding the voltage or current, I haven't mentioned any value. And here you are having, in the entire network you are having simply resistors. All the resistor values I have mentioned, and here I have mentioned the current flowing in this particular branch is 1 ampere. Okay, so all of you give a try. And here in this question I have kept two choices regarding the voltage across voltage source value, and two choices I have mentioned regarding how much current is flowing in this particular voltage source. Okay, right. So all of you give a try. I will give some time for all of you. I hope all of you will give the correct answer. I am expecting all of you to give the correct answer. Okay, don't take any pressure, just with free mind all of you give a try. This is a very interesting question. All of you give it a try. Please like and share this video so that even other students, even your friends will join in this live session and they also will get benefited from these questions which we are discussing. What are the concepts we are discussing? What are the methods of solving we are discussing? All your friends will get benefited. Whoever targeting for the upcoming GATE exam, that is GATE 2024. Yeah, this is a very interesting question. In this entire given circuit, you're having, other than this voltage source, remaining all are resistors. Remaining all are resistors. Okay. So in the earlier question also, we have solved by using series and parallel connection, right? Regarding the resistors, by using that series and parallel connection, or by using Ohm's law or KCL, KVL, whatever required, with the help of basic laws only, we can solve this particular question. Say for example, if they haven't given this voltage source, okay, symbol in this given circuit, in that question they can ask what is the R equivalent. What is the R equivalent across these two terminals? That time what you can do, okay, so in this way, say for example, you are keeping one unknown voltage source like this, okay, you can find out that particular voltage source value and you can find out the current flowing in that particular branch. After that, if you are taking ratio of voltage and current, from there also you will get equivalent resistance, okay. So that is one method, and whatever the earlier method we have discussed, with the help of these two, some questions you can solve with the help of that method, some questions you can solve with the help of this method. That is the reason I have given intentional this question like this, okay. So whatever this given circuit is there, they can ask this question. Instead of finding Vs and Is, they can find what is the equivalent resistance across this terminus. Okay, that time simply you have to find out the equivalent resistance. Okay, right. So for the time being, since they have asked what is the voltage source value and how much current is flowing in this particular branch, okay, now in this entire network, anyway these two are unknown. Okay, whenever those two are unknown, definitely we should not start from there, right? Yes or no? Because already these are unknown, you should not start from left hand side. Now you are getting the clue among entire network, in the entire network, if you observe, all the resistor values you know. But in addition to the resistor value, here only in this particular branch you know one extra value. What is that? You know the current flowing in this particular branch. Once if you know current flowing through a resistor and if you know the resistor value, you can calculate the voltage across it by using Ohm's law, right? By using Ohm's law, here you will get 4 into 1, that is nothing but 4 volts. 4 volts. Okay. Now can you tell in this 2 ohm resistor how much current is flowing? How much current is flowing? Here for understanding purpose, I have discussed regarding the voltage. Even without finding voltage also you can say, how just by the help of this one, you can say that how much current is flowing in this branch. Yes. See, these two are connected in what? Parallel. In parallel, voltage will be same. In parallel, voltage will be same. So by using Ohm's law, 4 divided by 2, that is nothing but 2 ampere. 2 ampere. Yes, very good, Manoj. Ritin. Yes, very good. So in parallel, voltage will be same, current will be distributed or current will be divided. Okay. So now just by observing in 4 ohm resistor, okay, the moment you have observed these two are connected in parallel, right? In 4 ohm resistor, if 1 ampere current will flow, obviously in 2 ohm resistor, when compared to the 4 ohm resistor, 2 ohm resistor is having less value. Okay. The resistor which is having more value, in that branch, if 1 ampere current will flow, when compared to this resistor value, this is half of that. Okay. If the resistance value is less, obviously current will flow more, right? Since here 1 ampere, obviously it is 2 ampere. Okay, right. Now, just observe, this is one point, node point, okay, node, right? To this node, this point is connected, right? These two are connected in parallel, we already discussed. Now, if you observe carefully, this point, this point, this point, all are same. This point, this point, this point, all are same, right? So, with this understanding, when you look at the circuit, these two only parallel. But if you carefully observe, in fact, this 4 ohm resistor is also in parallel to this 2 ohm resistor and 4 ohm, right? So in parallel, obviously voltage will be same, that is 4 volts. And by using Ohm's law, you are getting 1 ampere, right? Or otherwise, here also 4 volt, 4 ohm. In this branch, 1 ampere current is flowing. The moment you have observed this one, both are parallel, right? In this branch, 1 ampere, obviously same resistor here you are having, right? Same current will flow, same current. Okay. Now, here if you observe, so here if you observe, you are having one node, right? From this node, if you observe broadly if you observe, you are having 3 resistors which are connected in parallel, right? In this branch, 1 ampere current is flowing, in this branch 1 ampere, in this branch 2 ampere. Okay, say for example, to make simpler understanding, in this branch, okay, if you apply KCL at this particular node, in these 2 branches, current is leaving. So 2 plus 1, 3 ampere should enter. If 3 ampere is entering here, then together 3 ampere can leave. 3 ampere can leave. Okay. Now, if you apply KCL at this particular node, okay, 3 ampere, 1 ampere, together 4 ampere is leaving. So that means 4 ampere should enter. Then only 4 ampere can leave together, right? Now, in this branch, 4 ampere current is coming like this. By using Ohm's law, 4 into 3, that is nothing but 12 volts. 12 volts. Okay. Now, all of you tell me, what is the node voltage? What is the node voltage? Or what is the voltage across these 2 nodes? What is the voltage across these 2 nodes? Say, for example, I am labeling this node is like, say for example P, and this node is like, say for example Q. What is VPQ? What is the voltage across VPQ? Can you tell? See, it is very simple. We already mentioned, okay, between regarding VPQ, here plus minus, okay. Regarding VPQ, I am mentioning here, I want to find out regarding VPQ. Yes, very good, Ritin, very good. Here, between P and, suppose this is some another node, say for example S I am mentioning, okay. Between P and S, I got 12 volts. Between P and S, I got 12 volts, and between S and Q, I got 4 volts. Between S and Q, I got 4 volts. Yes, very good. All of you are giving correct answer, right? So here voltage polarities are plus minus, that means we will add, right? So 12 plus 4 is nothing but 16. 12 plus 4, which is nothing but 16 volts. Plus 4, which is nothing but 16 volts. 16 volts, right? Okay. Now, with this understanding, as I mentioned already, these 2 points I have simply connected with one wire. Similarly, if you observe this point, all are same, If this is Q, obviously this is Q. This is also Q. Now, all of you, when I have asked that what is the voltage across these 2 nodes, all of you applied. Just by observing these 2 voltages, you have given the value as 16 volt. That is correct. In a similar way, if you observe carefully, here you are having 2 ohm resistor, here you are having 4 ohm resistor, both are connected in parallel. Obviously, voltage will be same across these 2 elements. And in fact, here if you observe, left hand side, for both the resistors, you are having one node, that is P, and right hand side, for both the resistors, you are having one more node, that is Q. Okay, with respect to this branch, when you have told the voltage across these 2 nodes is 16 volt, obviously the voltage across these 2 nodes also will be same, right? So that means here you will be having 16 volts, here also same voltage 16 volts, right? This is the important key point. Okay, you have to analyze carefully. Okay, wherever required you can apply KCL, and whenever parallel connection is there, voltage will be same. Okay, whenever series connection is there, current will be same. Okay. Now you can use simply Ohm's law. 16 volt is there, 2 ohm resistor. That means 8 ampere is flowing. 16 volt, 4 ohm resistor. That means 4 ampere is flowing. 16 by 4 is 4. 16 by 2 is 8. Okay. Now with this understanding, if you observe, say for example, if you are considering this node, from this node you are having 2 branches. And in both the branches, current is leaving. 8 ampere, 4 ampere. Together 12 ampere is flowing, leaving from this particular node. That means here 12 ampere should enter to this particular node. I hope all of you are getting clarity. To this particular node, if 12 ampere is coming, then together 12 ampere can leave. Okay. Now, if you observe from this node, in this branch 12 ampere is flowing. In this branch 4 ampere is flowing. Together 16 ampere is leaving. That means here 16 ampere should enter. 16 ampere should enter. Then only together 16 ampere can leave. Okay. Now, here you are having one node. Okay. Right. Same point P, because both are, I have just connected with the help of single wire. Okay. Now, this node both are same, Q only. And this node both are same Q only. Now, can you tell this 1 ohm resistor, obviously, just by observing this connection, okay, some of you might have thought that we may have to apply like star to delta, delta to star. Not at all required. Sometime intentionally they will keep the question like looking like star delta conversion. We may have to apply. But if you carefully observe the connections, whether really required star to delta or delta to star. If really required, definitely you can apply. But wherever not required, if you are making unnecessarily, that means you are unnecessarily increasing the solving process or calculation part, right? I hope all of you are getting the clarity. Even though when you look at this particular configuration, it is looking like delta configuration. You might have thought initially we may have to convert into star, but not at all required. These two are connected in parallel. These two are connected in parallel, right? So here P point is same, here Q point is same. Regarding VPQ, we got 16 volt. Obviously, across this 1 ohm resistor, same voltage you will be having, right? Same voltage you will be having, 16 volt. Here also same voltage, 16 volt. This is a very interesting question I have kept in this particular session so that most of the students will get the clarity and good comment over the concept regarding basic concepts like series and parallel connection, right? And KCL, KVL, Ohm's law. Now, you know the voltage, you know the resistor, you can calculate the current, that is 16 ampere. Obviously in this branch also same current because both are having same resistor. Whenever resistors are having equal value, okay, if the resistors are connected in parallel, obviously same current will flow. Okay, just like here. Here between S and Q, 4 ohm resistor, between S and Q, 4 ohm resistor. In this resistor, if 1 ampere flows, obviously in this resistor, 1 ampere will flow. Because in parallel, voltage should be same. The moment if voltage same and resistor value same, obviously the current flow through the equal resistors which are connected in parallel, obviously it will be same or equal value, right? So as of now, if you observe, in this branch 16 ampere is flowing, in this branch 16 ampere is flowing, in this branch 16 ampere is flowing. So in all the three branches together, how much current is leaving? 16 plus 16 plus 16 together 48. So that means here 48 ampere should enter. If 48 ampere is entering, then together 48 ampere can leave. Okay, right. So here 48 ampere is coming like this. Now by using Ohm's law, can you tell how much voltage you are getting here across this 0.5 ohm resistor? All of you can answer. See here 48 ohm and 48 ampere current is flowing and 0.5 ohm resistor is there. 0.5 is nothing but what? 1 by 2. 1 by 2 into 48, that means 24 volts. If it is 1 ohm, then 48 volts. Correct? Yeah, very good, Ritin. Now, if you carefully observe, here you are having what? Closed path. You are having closed path. You can find the voltage. You can find the unknown voltage or the voltage across this particular branch. Yes or no? Because you know the voltage here, you know the voltage here. Okay. You can find the voltage across this particular branch. Now, if you carefully observe, so if you want, you can apply KVL, but for easy understanding, okay, here left hand side we are having plus minus polarity, okay. Now, the other two branches, okay, just keep vertical alignment. So first I am considering this one, 16 volt. And okay, whatever this 0.5 ohm resistor here you are having horizontal, for the timing I am keeping vertical alignment. The moment if you are keeping vertical alignment, the polarities you will get plus minus. Here 24 volt. I hope all of you are getting the clarity. Of course, by the help of KVL only you will get the same answer, but without writing KVL, how easily we can find the unknown voltage in a closed path. Okay, whenever you know the voltage across remaining branches, if you know, how easily we can do the calculation part, whether addition operation or subtraction operation, right? Yeah. So here plus minus polarities are there. These two elements I kept vertical. So first of all I have considered this one 16 volt, and then the moment you have kept this resistor like this, voltage polarities are getting plus minus, and both are having same polarities. Yes, very good, Manoj. So that means you can add the resultant voltages. Okay, what are the individual voltages you are having? You can add. So 24 plus 16, that is nothing but 40. 24 plus 16, that is 40. 40 volts. 40 volts. Right. So as of now we got the voltage across this 1 ohm resistor is 40 volt. 40 volt. Now tell me, with this understanding, can you tell what is the voltage, the supply voltage value? For this entire circuit, you are having one voltage source. Can you guess what is the voltage source value? Yes, it is very simple. Just observe. For this resistor, one terminal and this voltage source, one terminal it is matched, right? Now if you observe, this point, this point, this point all are same. This point, this point, this point all are same. So that means this is Q. Say for example, earlier I have considered like PQ. Yes, I have considered. R I haven't considered because in general resistor we will use the letter R. Okay. So for timing I am considering the other letter like say for example T. So between T and Q, you're having voltage source. Between T and Q, you're having 1 ohm resistor. 1 ohm resistor, right? Yes, very good, Manoj and Ritin. Okay. So these two are connected in parallel only. So in parallel, voltage will be same. The moment you got voltage across this 1 ohm resistor is 40 volt, directly you can say the Vs is 40 volts. The voltage polarity is anyway here you're having plus minus, right? Suppose in this question, if they could have mentioned opposite way, the voltage polarities, then Vs value will be minus 40 volt. Okay, just like in one of the earlier question. But in this question, after doing calculation like this, if you are getting the value as positive, so that means whatever the convention they have considered, that is correct only. The moment if you are getting negative, that means you have to change the polarities, actual or real sense, like that. Yes, very good Manoj, very good. So here you know the voltage, you know the resistor, you can find the current flowing in this branch, 40 by 1, that is 40 ampere. So at this node, in these two branches, 40, 48 is leaving. That means together 88 ampere is leaving. So obviously if 88 ampere is entering, then only together 88 ampere can leave. Okay, right. So finally we got Vs and Is. Vs is 40 volt. Yes, option B is satisfying. And regarding Is, 88 ampere. 88 ampere. Option B and option D, both are correct. Okay, right? So how many of you liked this question? All of you please mention in the chat. How many of you felt this is a very interesting question? How many of you liked this question? You can mention in the chat. Yes, I hope all of you felt this is a very interesting question. Okay, here simply we have used the KCL, KVL and Ohm's law wherever required. Okay, right. This is the NIT question. Answer will be a number. I hope you might have solved similar kind of questions in the previous gate papers also. Okay. So regarding the resistors, you will get whatever the earlier models we have discussed like series, parallel or parallel series, and you will get like star delta, delta to star questions, or you may get infinite ladder network questions regarding the equivalent resistance concept. Okay. So for the timing here, in this particular question, I have considered the infinite ladder network. So all of you give it a try. In this entire network, you're having 5 ohm resistor, 10 ohm, 5 ohm, 10 ohm, 5 ohm, 10 ohm, 5 ohm, 10 ohm. Like this network is continuing up to infinity. For this overall network, you're having the terminals A and B. So across the terminals A and B, what is the equivalent resistance that you're going to get? Okay, that you have to calculate for this particular question. So whoever might have studied the concept regarding infinite ladder network, those students can attempt and definitely will get the correct answer. Whoever not having the knowledge, okay, no issue at all, I will discuss after some time. Yeah, we are getting different answers for this question. Yeah. Yeah, Manoj, your answer is correct. Okay, Ritin, you can cross check. Okay. So here if you observe in this entire network, 5 ohm, 10 ohm, 5 ohm, 10 ohm, 5 ohm, 10 ohm. Like this 5 ohm, 10 ohm, that part of the network is repeating and it is going up to infinite, Okay. So for this overall network, when you are looking from the terminals A and B, when you are calculating, say for example, after calculating the equivalent resistance, you will get one single resistor. The overall network you can replace with one single resistor, right? So that equivalent resistance that you are getting, say for example, R equivalent, I am assuming. Now, here the terminals AB I have mentioned. For the time being, I am mentioning the terminals here, C and D. For the time being, I am mentioning the nodes as C and D. Okay. Now, say for example, when you are looking the overall network from the terminals A and B, that time you got equivalent resistance as R equivalent. Now, for the time being, whatever the first section here I am having, I am just removing that section. Now, between C and D terminals, when I am looking this entire network, whatever the resistance I am getting, that resistance will be equal to this one or not? Say for example, if you are considering sea or ocean, okay, there lot of water will be there, right? Say for example, if I have taken one drop water from the ocean or sea, whether the level of that ocean or sea will change. If I take one drop water from the ocean or sea, same water will remain, right? Or I can say that whatever the drop of the water that I have taken from the ocean or sea, that is negligible, right? In a similar way, when you are having this infinite ladder network, okay, like this 5 ohm, 10 ohm, 5 ohm, 10 ohm, that connections you are having up to infinite, right? So when you are looking from the terminals A and B, that time whatever the equivalent resistance you are getting, okay, now from this entire infinite network, the moment if I have taken one section, just I have ignored or I have removed one section from infinite sections. Now, when you have considered the overall network, you are having infinite sections. Out of infinite sections, I have taken one section out. Now, I am considering the rest of the network. Obviously, you will get the same equivalent resistance because you are having infinite sections, right? When you are having infinite sections, the moment if I am taking one section out, still you will get whatever the equivalent resistance earlier you got, same equivalent resistance. I hope all of you are getting clarity. Okay. Now, whatever this entire network you are having, to the left of the terminals, to the right of the terminals C and D, this overall network you can replace with one single resistor, that is R equivalent. So now you are having 5 ohm resistor, you are having 10 ohm resistor, and then here you can connect one single resistor which is having R equivalent. Okay, I hope all of you are getting clarity. Say for example, here I am just representing whatever the simplified network which we are getting. Here 5 ohm resistor, then 10 ohm resistor, then once again here I am placing R equivalent. Okay, just for reference I am labeling the nodes AB. So here C and D. Okay. To the right of C and D, the entire network I have replaced with one single resistor, and here to the left of C and D you are having one resistor 10 ohm. After that here you are having 5 ohm. Okay. Now these two are connected in parallel. So you will get 10 into R equivalent divided by 10 plus R equivalent. Now you are getting one single resistor, right? Now you are having 5 ohm resistor and that one resistor. These two are connected in series. So here you will get R equivalent as just addition of these two resistors, right? So R equivalent equal to here 5 ohm plus 5 ohm plus, just now you got that single equivalent resistance, 10 times R equivalent divided by 10 plus R equivalent. R1 R2 divided by R1 plus R2. Okay, I hope it is clear up to this step. Is it clear, Ritin? Now you can do the LCM here on the right hand side. In the denominator you will get 10 plus R equivalent. 10 plus R equivalent, right? So here you can multiply 5 into 10, that is 50, plus 5 into R equivalent, plus here you are having 10 times R equivalent. 10 times R equivalent, right? Left hand side you are having R equivalent, you can keep as it is. Now you can do the cross multiplication. 10 times R equivalent plus R equivalent square. On right hand side you are having 50 plus, okay, I am keeping as it is, 5 times R equivalent plus 10 times R equivalent, right? 10 times R equivalent will get cancelled on both the sides, right? So from here we are getting one quadratic equation, R equivalent square minus, okay, I am bringing these two terms right hand side, it will become negative. R equivalent square minus 5 times R equivalent minus 50 is equal to 0. Whenever you are having quadratic equation, I hope all of you know how to find the roots. Ax square plus bx plus c equal to 0, right? So from there you can calculate the roots by using the standard formula, like minus b plus or minus square root of b square minus b square minus 4ac. Here a value is 1 into c value is minus 50 divided by 2 times c. Divided by 2 times c. So here a value is 1. Okay, right. Now you can do further simplification. Minus of minus, that is plus 5 plus or minus square root of 5 square is 25, minus into minus plus 450s are 200 divided by 2. Okay, so from here you will get R equivalent as 5 plus or minus 25 plus 200, that is 225. Root 225 is nothing but 15 divided by 2. So 5 plus 15, that is 20 divided by 2. 5 minus 15, that is minus 10 divided by 2. So from here you are getting 10 and minus 5. So here when you are solving any quadratic equation, if you are getting negative root, okay, in your mathematics we will consider. But here you are having what? Resistor. Obviously the resistor value should be positive. That's why we will ignore. After solving any quadratic equation like this, if you are getting resistance value negative, you can ignore. Okay. So the final answer for this question is R equivalent equal to 10 ohm. R equivalent equal to 10 ohm. Because in this network, if you observe, all are resistors only. And in fact, in general, we will represent resistor value positive unless otherwise source. Okay, sources when you are studying transistor or FET, etc. Okay, so because those are sources, okay, so they will be having negative resistance. Okay, but here all are passive elements, right? All are passive elements. Okay, so whenever you are having passive elements, obviously, whenever you are having passive elements, after calculating the equivalent resistance, obviously you will get positive resistor value, right? So that is the reason. Whenever you are having some dependent source, etc., that time if you are solving any question regarding the equivalent resistance, sometime you can get negative because it is a source. But whenever you are having resistor network, obviously the resistor value, after finding the entire equivalent resistance, you are going to get single resistor, right? So all the practical resistors you can represent positive value only, right? That is the reason. That is the reason we can ignore negative value. Okay, right? So all of you please respond, is it clear or not? So the final answer for this question is 10 ohms. Yes, I hope it is clear for everyone. Okay. Now whatever the here procedure I have discussed for finding the roots. Okay, this is one procedure. Okay, now I am giving one more procedure in order to find out the roots. Okay, in order to find out the roots. Say for example, if alpha and beta are the two roots, if alpha and beta are the two roots, okay, then sum of the roots formula is what? Minus b by a. Sum of the roots equal to minus b by a, right? So here in this question, if you observe, here b already you are having negative. So minus of minus 5, that is nothing but 5 divided by a value is 1. So that means you are getting 5. Or if you want, I will represent more clearly like this. Next, similarly, product of the roots. Product of the roots equal to c by a. C by a. So here c is nothing but minus 50. C is nothing but minus 50 divided by a value is 1. So from here you are getting minus 50. Okay. Gunnar, is it clear? I hope all of you studied regarding quadratic equation, how to find the sum of the roots, how to find the product of the roots, right? Sum of the roots equal to minus b by a, product of the roots equal to c by a, right? So once if you know these two, okay, I hope all of you might have studied or learned this formula during your mathematics, okay, in the school standard or intermediate. Once if you know a plus b, once if you know a and b, okay. So here we can calculate a minus b value by using this formula. Alpha minus beta whole square equal to alpha plus beta whole square minus 4 times alpha beta. See, alpha plus beta whole square is nothing but alpha square plus beta square plus 2 times alpha beta plus 2 minus 4. That means you are getting minus 2 alpha beta. So together you are getting alpha minus beta whole square. Okay. Now you can substitute alpha plus beta value is 5. So here you can substitute 5 square minus 4 into alpha into beta. According to the given question, you are getting minus 50. Now 5 square is 25. Minus into minus plus 450, sir, 200. That means you are going to get 225. 225. Okay, alpha minus beta whole square is 225. Alpha minus beta whole square is 225. So from here you can write alpha minus beta equal to 15. So here alpha plus beta you are having 5. That one I am labeling as equation number 1. And alpha minus beta as 15. That one I am labeling as equation number 2. Okay. So equation 1, equation 2, if you are adding 1 and 2, if you are adding, then beta will get cancelled. Left hand side you are going to get 2 alpha. And right hand side if you are adding 5 plus 15, that is nothing but 20. So from here alpha equal to 20 by 2, that is nothing but 10. So here alpha is nothing but equivalent resistance, that is 10 ohm. That is 10 ohm. The moment if you got one root, you can substitute either in equation 1 or equation 2, or maybe in this, suppose if this one if you are labeling as equation 3. With the help of any of these 3 equations, once if you know one of the root, you can find the unknown, right? Say for example, if you are considering this one, whatever alpha value got, if you are substituting in equation 1, alpha value is 10 plus beta is equal to 5. So from here you are getting beta value as minus 5. So that means resistor value never be negative. So that is the reason we are eliminating. Okay. So I have given earlier one approach with the help of standard roots, how to find the standard roots for any quadratic equation. By using that formula I have discussed. Now I have given one more approach. So whichever approach you feel comfortable whenever you are supposed to solve any quadratic equation, you can follow. Right. I hope all of you are familiar regarding both the methods. So just for understanding, I have given a recap of another approach. Okay. Yeah, this is the next question. And here I have kept this question as MCQ. That means obviously among the given choices, among given 4 choices, obviously one option will be correct, right? So up to previous question, I have discussed most of the questions MSQ and few questions as NAT. But first time I have given MCQ question. So I hope some of you will feel happy because I have given MCQ. Obviously one option will be correct, right? So all of you give it a try. Yeah, thank you Gopal for your compliment. All of you try this question. This is a very interesting question. Up to now, the previous questions which we have solved from the first chapter, right? So if you want, I am giving the hint for this question. If you want, you can use the any theorem from your second chapter. So now we are going to start the questions regarding network theorems. That is second chapter. Up to previous question, we have discussed the questions or concepts related to the first chapter. Okay, if you want, you can apply any network theorem, or if you know any other procedure or method. Okay, so whichever method you are comfortable, you can give it a try. Anyone tried? So whatever the answer you feel correct, you can mention. This is MCQ. Already you're having choices in front of you. You can choose whichever choice you feel correct after solving this question, right? So in this particular question, you're having current source, you're having voltage source, and then resistors are there. In this particular question, the current flowing through 20 ohm resistor, they have given the current direction like this. So you have to find out the current value in this question. Okay. So for the time being, for understanding purpose, I will discuss this question by using superposition theorem first. Okay. After that, I will discuss other methods also. Yes, very good, Ritin. Very good. Excellent. So for the time being, let us solve this question by using superposition theorem. Method 1, superposition theorem. So whenever you're having multiple sources present in the given network, so when all the sources present, that time if you want to find the response of any particular branch, either response means either current or it can be voltage, right? So what you can do, you can consider one source at a time. You can find the response. After that, you can perform when you can consider individually one source at a time. So because of each source, whatever the response you are getting, later you can perform the resultant sum. Okay, right. So first of all, I am considering, say for example, 18 ampere current source. That time what we have to do regarding this 9 volt source? All of you please respond. Case 1 I am considering only 18 ampere current source. Okay, so that time the other source here 9 volt, that is a voltage source, right? So this voltage source, whether we have to make short or whether we have to make open circuit. All of you please respond. So what is the given circuit is there? Entire circuit I have kept as it is. Now all of you please respond here what we have to do. Regarding this voltage source, act as per the given circuit. Whenever you are having voltage source, we have to make it as short. We have to make it as short when you are considering other source. Okay, right. So here, the moment you have shorted here, so this point, both are same. This point, both are same. Right. The moment if these 2 points are same, these 2 nodes are same, how 10 ohm and 20 ohm are connected? And similarly, how 40 ohm and 20 ohm are connected? All of you please give a try. The moment I have made voltage source as short circuit, then all the points or all these nodes become like same. Because of that, 10 ohm, 20 ohm, how they are connected, similarly 40 and 20, how they are connected. So meanwhile, I will draw the circuit diagram. Yes, all of you easily can answer, right? See, between these 2 points, we are having one resistor. Between these 2 points, we are having one resistor, and these two nodes are same. That means these 2 are connected in parallel. These 2 are connected in parallel. Okay, so here you are having 10 ohm resistor, and here you are having 20 ohm resistor. Okay, just for better understanding, I am drawing the equivalent circuit like this. Okay, you will get more clarity why I am drawing like this. Similarly, these 2 points are same. Okay, and 40 ohm, 20 ohm. Once again, they are connected in parallel. Forty ohm, 20 ohm, they are connected in parallel, right? Now all of you please respond whatever the given circuit by considering case 1. In case 1 we have considered only current source, the other voltage source we have made short. The moment you have made short, now whatever the circuit you are having, now I have drawn the equivalent circuit like this. All of you please respond whether this is the equivalent circuit for the above circuit or not. All of you please respond. Yes, both are equivalent, right? Both are equivalent. Here 10 ohm, 20 ohm, they are connected in parallel. Here 40 ohm, 20 ohm, they are connected in parallel. Why I have drawn like this? Because the moment if you have drawn like this, then only you can easily solve this question. Otherwise, you may face the problem. You may face the problem. Okay. Or you may be taking more time for solving this question. Okay, right. So just observe carefully. Just observe carefully. In this entire network, 18 ampere current is flowing. 18 ampere current is flowing. So that means here 18 ampere current is flowing. The moment if these two are in parallel, right? So in this branch some current will flow. In this branch some current will flow. After that, these two currents will enter here and together will leave whatever the entering current is there, same current will leave from this entire network together, right? Now, whatever the current here entering, and since these two are in parallel, here some current will flow, here some current will flow, and together, once again, from this particular network, 18 ampere will leave, so that in this entire network, overally 18 ampere current is flowing, right? Now, once if you understand this mechanism, right, you can easily calculate the current by using which principle or which rule? Current division rule, right? By using current division rule, you can calculate this current. Okay, by using current division rule, we can calculate. By using current division rule, we can calculate the current flowing through any resistance. Okay, whenever you are having two resistors which are contained parallel, and for this network, if you know the entering current or supply current, right? So by using current division principle, entering current we are considering, that is 18 ampere into among these two resistors. Here we want to find the current flowing in this particular branch, so that means opposite resistance value we have to consider, that is 10 ohm divided by sum of these two resistors, so that means 10 plus 20. So 10 plus 20 is 30, so that means you are getting 18 into 10 divided by 30. So here 0 will get cancelled, 6 times. So that means you are getting 6 ampere. So when we have considered only 18 ampere current source, okay, so that time, because of that particular current source, in this 20 ohm resistor, the current flowing is 6 ampere. 6 ampere current is flowing, right? I hope all of you got the clarity up to this step. Now we have to consider in the given circuit, now in this case, we have to consider this voltage source and we have to disconnect this particular current source, right? So when you are considering voltage source, the current source we have to make it as open. Current source, if you are making open, that means in the open circuit terminals, 0 ampere current is flowing. So that means we are not connected this particular current source, like that, okay? Right? So now let us consider this voltage source and we'll make this current source as open. That is case 2. I am considering only 9 volt source. Okay. So the moment I have removed the current source, here the terminals become open. If the terminals become open, how much current will flow? 0 ampere. Right? Okay. Now with this understanding, the moment if current flowing in this branch or this branch is 0 ampere, now can you tell how these two resistors are connected? Similarly, how these two resistors are connected? All of you give it a try. The moment if current flowing in this branch or this branch is 0 ampere, because of that, how these two resistors are connected? Meanwhile, I will just represent whatever the equivalent circuit we are having. All of you easily they can answer. Everyone can answer, right? See, just observe here at this particular node, actually you're having 3 branches. Okay. The moment if you know in one branch the current is 0, that means the other 2 branches simply they are connected in series. See, if there is some current flowing here, definitely here you have to apply KCL. Okay. So accordingly different current may flow or same current can flow. That is based on the given resistor values. Okay, according to the voltages, etc. Okay. But here The moment if you know, even though to a particular node, if 3 branches are connected, the moment if one of the branch current is 0 ampere, because of that, you can say that the other 2 branches simply they connected series, that's all. Or otherwise, say for example here 0 ampere current is entering, right? So in these 2 branches, okay, say for example if you are applying KCL, okay, in this branch whatever the current enter, same current should live like that. Okay, so even if you apply KCL also, you will come to know that it is they are connected in series. Like so here 10 ohm and 20 ohm they are connected in series. After that, say for example here I am considering this is like point A and this is point B, node A, node B. Between A and B we are having, say for example this one if you want, you can call it as C node, and this one is say for example D node. Okay, so between A and C we are having, between A and C we are having 10 ohm, and between C and B we are having 20 ohm resistor, and in the 20 ohm resistor how much current is flowing, that one they have labeled as I. We have to calculate that one. Okay. Now between A and D we are having 40 ohm resistor, between A and D 40 ohm resistor, and between D and B 20 ohm resistor. Between D and B 20 ohm resistor. Okay, and if you carefully observe here between A and D, right? So these 2 points we have to short. Okay, now between A and B you are having one voltage source. Its value is 9 volts. Between A and B you are having 9 volts. Okay, I hope all of you are getting. Okay, when you look at directly this particular circuit, some of you might be having the doubt how these 2 are connected in series. Similarly, how these 2 are connected in series. Now you can, the moment you have drawn the network like this, you are having here one more branch, but in that branch there is no current flowing. The moment if there is no current flowing, whatever the current entering here, same current will leave. Similarly, here also in this branch if no current flows, that means whatever the current enter here, same current will flow like this. Okay, right. Now just observe here these 2 are connected in series. In series we can add the resistors. Right? So 20 plus 10 that is nothing but 30 ohms. 20 plus 10 together 30 ohms you are getting, right? And here in parallel voltage will be same. So now by using basic Ohm's law you can calculate the current flowing in this particular branch, right? So we know the entire network across the terminals A and B we are having 9 volts, and here the equivalent resistance is 10 plus 20 because they are connected in series. In series current will be same. So 9 divided by 30. So 3 3s are 9, 3 10s are 30. So 3 by 10 that is nothing but 0.3 ampere. 3 by 10 that is nothing but 0.3 ampere, right? So this is case 2. Say for example here I am labeling as I2 because I have mentioned case 2. Similarly in case 1 whatever we have calculated, so for the timing I am labeling as I1. So with respect to case 1, the current flowing in this 20 ohm resistor is 6 ampere, right? In case 2, the current flowing in the same 20 ohm resistor in the same direction. We got 0.3 ampere. Now all of you please respond by using superposition theorem. Whether we have to add both the currents or whether we have to subtract the currents. All of you please respond. By using superposition theorem, here I equal to I1 plus I2. See in case 1 In case 1 we are having I1 direction like this, and in case 2 we are having I2 current direction, same thing. We haven't changed the direction of the current, right? So if you haven't changed the direction of the current, obviously whatever the current values you are getting, you can add. Okay, suppose if you are changing the current direction, then that time you have to do subtraction. Okay, right. So I equal to I1 plus I2. So in case 1 we got 6 ampere, in case 2 we got 0.3 ampere, right? So 6 ampere plus 0.3 ampere, so that means 6.3 ampere. 6.3 ampere. Okay. Yeah, the correct answer for this question is option B. Option B is the correct answer. Yeah, only Ritin has got the correct one. Very good. Okay, even other students also please respond. At least by now, is it clear for everyone or not? For the given question, especially the current flowing through 20 ohm resistor is 6.3 ampere. Okay, so for the timing, I have solved this question by using superposition theorem. Whenever you're having multiple sources present in the circuit, okay, with the help of superposition theorem, whatever the calculation part, okay, with the help of one source, you can do the calculation part easily. Okay, since you are considering only one source at a time, the rest of the circuit you may get in the combination of series connection or parallel connection, etc., or simple nodal, whatever the basic concepts that you might have studied or methods or laws that you have studied in the first chapter. With the help of any of those laws or methods, okay, based on the possibility, whichever laws and methods required, you can apply. Okay, so that means whatever the given circuit or network you are having, when multiple sources are present, wherever with the help of superposition theorem, you can easily solve, that time you can apply. Okay, right. So here for understanding purpose, I have solved this question by using superposition theorem in first method. Now, I will discuss this question in one more method. So, can you guess by using which method I am going to solve this question? I will solve this question in 3 methods. As of now, I have solved this question in superposition theorem method. Okay. Can you guess what is the next method? Yeah, just observe here. Just observe here. In this particular branch, we have to find the current. In this particular branch, we have to find the current, right? Okay. Now, if you carefully observe, say for example, here I am mentioning the labels, okay, or points or nodes as, say for example, this is point A, this is point B, and this is point C. Okay. Similarly, if you want, you can consider this is like point D. This node point is D. Okay, right. Okay, now just observe, from the given circuit, between the nodes A and B, you know the voltage source value, that is 9 volt. So that means this 9 volt is nothing but the voltage difference between these two nodes. Okay. Say for example, if you are considering this is 10 volt and this 1 volt, 10 minus 1 is 9 volts, or 11 volts if you are considering, 11 minus 2 is 9 volt. Accordingly, see, by considering various B at B node, if you are considering different voltages, accordingly, here you can consider the node voltage in such a way that the difference of node voltages between A and B, you should get 9 volt. Okay, but here for solving the question in easy manner, better you can choose this node voltage as ground. That means 0 volt. Okay, that means here the moment you have chosen the node voltage VB as 0 volts. Node voltage at B as 0 volt. That means here VA minus VB, according to the given question, you are having 9 volts. Okay, but in this question, I have considered, for easy understanding, I have considered VB as 0. So the moment if VB is 0, VA is nothing but 9 volts. Okay, if you want, you can consider other than 0 volt, you can consider any value. Accordingly, you have to find out the corresponding VA. But if you want to do the calculation simpler, right? So that time better you can choose that node voltage as 0, right? Now you are getting in this question VA as 9 volts. In this question you got VA as 9 volts. Now this node voltage with respect to ground, that is nothing but 9 volt. Now if you carefully observe this node point, okay, here if you are considering this node, so in general if you observe here between this node and here, okay, you are having one resistor, and in general we'll consider this node as ground. Okay, if you are considering this is the ground, then this node voltage with respect to ground is nothing but the node voltage at this particular node with respect to ground, that is nothing but VA. So that node voltage is same as the voltage across this particular resistor. The voltage across this particular resistor 40 ohm, right? Is it clear for everyone? In general, always we'll consider whenever you're having circuit, right? So for solving any circuit or network, okay, you can consider one of the node as ground or reference node. Okay, in general we'll consider the ground node at the bottom. Okay, but even if you're considering any other node also ground, okay, you can get the same calculation. But in general we'll consider node at the ground node at the bottom, so that you can solve the question in the simpler manner or easy manner. Okay, right. So the moment if you have considered this is the ground, the node voltage with respect to ground is nothing but VA. Okay, and that is nothing but the voltage across this particular resistor. Voltage across this particular resistor. Right. Now just observe. Here you are having, in this example I have considered this node voltage as 0 volt. Okay. Even if you want, you can consider any other voltage also. Suppose if you have considered 2 volt or 3 volt like that, say for example. In that case, this node voltage with respect to ground is nothing but VB. Okay, but in this case, this node voltage with respect to ground itself 0 volt. And here the node voltage is 0. Here also node voltage is 0. So, now can you tell how much current will flow in this particular branch? How much current will flow in this particular branch? Yeah, it is very simple, right? So whenever you're having any practical resistor and the resistor which is having non-zero value, right? If you're having end-to-end voltage the same, that means the voltage across that particular resistor or the difference of those two node voltages is 0. Here in this case 0 minus 0 is 0. Okay, and 0 by 20 ohm, obviously you'll get 0 ampere. 0 ampere. Okay, now here we have to find the current flowing in this particular branch. Okay, and here according to this particular given diagram regarding the voltage source, with respect to that, the moment if you have considered this node voltage as 0, obviously this node voltage is 9 volt. Okay, just for understanding I have discussed these two concepts. Okay, but the moment you got here, this node voltage with respect to ground is nothing but 9 volt, and this node voltage is 0 volt, and this node voltage we don't know, you can assume as V suffix C. V suffix C. Now, if you write one nodal equation here, with the help of one nodal equation, one unknown node voltage is there, obviously you can do the calculation. You can find the unknown voltage, right? So here 18 ampere current is entering. Entering current we will consider negative. Here I am writing the nodal equation. Here I am writing the nodal equation at node C. Okay, so here entering current is negative, that is minus 18 ampere, plus sum of all the leaving currents equal 0. Since I know the current direction, I have considered entering current is negative. Whenever current direction is not given, you can assume that currents are leaving. Okay, so in this particular branch, already they have mentioned current is leaving, that is I. Now, by using Ohm's law, you can write VC minus 0 divided by 20 ohm. VC minus 0 divided by 20 ohm. That is the current flowing in this particular 20 ohm resistor. Similarly, in this branch, you can assume that current is leaving. Current is leaving. Whenever current direction is not given, you can assume that the currents are leaving from that particular node, so that you can write the equation easily. If you want, you can assume in all the branches current is entering. Okay, sum of all the entering currents equal 0, sum of all the leaving currents equal 0, or sum of entering currents equal to sum of leaving currents. All the equations will hold. Okay, right. So here in this branch, how much current is flowing? VC minus 9 divided by 10 is equal to 0. VC minus 9 divided by 10 is equal to 0. Okay, so in this entire equation, you are having only one unknown voltage, so you can easily calculate. So for the time being, here you can take the LCM. LCM will be 20. 20 into minus 18, you will get minus 360 plus VC plus. Here you can multiply 2 times. 2VC minus 18 is equal to 0. Is equal to 0. Okay, just do the cross multiplication. 2VC plus VC, that is 3VC. Right. Minus 360 minus 18, that is minus 378 is equal to 0. From here you will get VC equal to 378 divided by 3. 378 divided by 3. Okay. So from here you will get 3 1s are 3, 3 2s are 6, 18. 3 6 are 18. Right. Units are volts. But here they are asking current flowing in the 20 ohm resistor. By using Ohm's law, we can write I equal to, here already you are having ground. So that means voltage across this 20 ohm resistor is nothing but simply VC. Simply VC. So I equal to, if you want you can write one step like this, VC minus 0 divided by 20. So that is nothing but VC by 20. So here VC value we got 126 divided by 20. So for the time being, since in the denominator you are having like 10, because of that you can write the numerator like this, 12.6 divided by 2. 126 divided by 10 is nothing but 12.6, right? 12.6 divided by 2. So this one you are getting 6.3 ampere. 6.3 ampere. Same answer. Same answer. Okay. Okay, I hope all of you are getting the clarity regarding the nodal analysis. Okay, with the help of nodal equation, we solved this question, right? Now can you guess? We will solve the same question by using one more method. So can you guess this method? Can you guess, all of you? I will discuss one more method. All of you mention the name of the method. Yeah, Ritin, here Wheatstone bridge is not required. Wheatstone bridge is not required. See, Wheatstone bridge concept, that time here you will be having galvanometer, right? Here you will be having galvanometer. If the bridge is balanced in this particular branch, the current flowing through it is 0. If the bridge is balanced, okay, right? But here actually we are solving this question by using superposition theorem. Okay, initially I have explained with the help of superposition theorem. So that means currently we are solving the question based on the second chapter concept. But okay, after that I have explained with the help of nodal equation also. Now, since I have discussed nodal equation, now you can guess that here I am going to discuss the mesh analysis. Okay, with the help of mesh analysis, this question you can easily solve. Okay, right. Say for example, here just by observing this circuit, how many meshes you are having? How many meshes you are having? 3 meshes, right? This is one closed path, this is one closed path, this is another closed path. 3 meshes are there, right? So for the time being, in this mesh, I am labeling the mesh current as I1. Similarly, in this mesh, I am considering the mesh current as I2. Similarly, in this mesh, the mesh current is I3. Mesh current is I3. Right? Okay. Now just observe. In this mesh, the mesh current is I1. Okay. And here, in this mesh, you are having one current source, and this current source is not common. For any of the two meshes. Right? So this current source is only part of first mesh only. So whenever you're having like that, so that means the current source value here in this particular branch, 18 ampere current is flowing, right? So this is the branch current, and in this particular mesh, the mesh current flowing is I1, right? So whenever you're having any branch current value, if you know, and if that branch is only part of one particular mesh, then the branch current and mesh current both are same. So with this understanding, we can directly write I1 equal to 18 ampere. Similarly, here if you observe, here in the 20 ohm resistor, the current I is flowing, and here only this 20 ohm resistor, whatever the current is flowing, that is only part of this second mesh, right? And here I have considered the mesh current as I2, right? The mesh current and branch current both are same, right? So with this understanding, I2 equal to I. Okay, right. So here I current is flowing. So by using Ohm's law, the voltage across this particular resistor is 20I. Okay. Now, can you tell in this particular branch how much current is flowing? When you write the mesh current, okay. So I2 current is flowing like this. Whereas I1 current is flowing like this. So that means in this direction, I2 minus I1 is flowing. Where I2 is nothing but I. And I1 is nothing but 18. I minus 18 current is flowing like this. Now, whenever current is flowing like this in the resistor, positive terminal here, negative terminal here. Now you can apply KVL around this particular loop. Okay, you can apply KVL around this loop. So if you are writing KVL around second mesh, okay. So for the time being, I am writing clockwise. Okay, you can consider any order, no problem. So here plus 2 minus 20I, then minus 2 plus 9, then plus 2 minus 10 into I minus 18. I minus 18 is equal to 0. Sum of all the voltage drops around a closed path is equal to 0. Okay. So here 20I plus 10I. So that means 30I plus 9 I am keeping as it is, minus of minus, that is plus 10 into 18, that is 180 is equal to 0. So from here 30I we can bring right hand side, it will become positive. Left hand side you are going to have 189. From here you can write I equal to 189 divided by 30. So here also 189 divided by 10 you can write as 18.9 divided by 3. 18.9 divided by 3. So from here you can write 6.3 ampere. Here for understanding purpose I have written mesh equation, but this question without using pen and paper directly you can solve. Okay, the moment you have observed like this, here obviously the current is entering like this, voltage polarities are plus minus. Similarly, current is entering like this, mesh current, voltage polarities are plus minus, right? So that means obviously when you are writing mesh equation like this, here negative terminal is the leaving and here also negative terminal is the leaving, right? So that means these two voltage drops you have to add. Whereas here, second terminal is positive, so that means this is the supply, right? So this voltage should be equal to sum of these two voltage drops, okay? So the moment when you have analyzed like this, here 20I plus 10I, that means 30I, and then here you are getting 189. So you can do this simple calculation without using pen and paper, right? So in this way, wherever there is a possibility, try to solve the given question without using pen and paper. For understanding purpose, I have solved this question by using superposition theorem, right? After that, I have discussed nodal analysis. Now I have given the mesh analysis, right? So for this question, suppose if you are getting like this question in the GATE exam, for solving this question, the best method is mesh analysis. Okay. So in this particular session, we have discussed variety of questions. We have covered the first chapter and second chapter. Regarding second chapter, I have discussed one question based on superposition theorem, right? So we are having one more question regarding second chapter, but for the time being, I am giving this question as homework. This is the homework question. All of you give it a try. This is the homework question. All of you take the screenshot. This is the question based on maximum power transfer theorem, and this question is of MSQ. Either one option or more than one option can be correct. So here, just by observing options, two options are related to RL value, two options are related to PL max, right? So at max among option A, option B, one option can be correct. Similarly, among option C and option D, at max one option can be correct, right? So all of you give a try. Regarding this question, whatever the answers you are feeling correct after solving this question, you can mention in the comment section. You are having time till tomorrow 6 o'clock, right? So tomorrow we are having one more session. So the continuation session we are having regarding network theory. So in that particular session, at the beginning I will discuss this question. After that I will discuss the questions based on remaining chapters, right? So I hope all of you got the clarity and good comment over the network theory subject regarding whatever the questions we have discussed so far, right? Okay, all of you try this question in your free time till tomorrow 6 o'clock, right? So for the time being, I am stopping here. We'll meet you all on tomorrow at 6 p.m., right? So I hope all of you will try this question, right? So all of you please mention how many of you are going to try this question before we are going to start this question. We are starting this question on tomorrow, in tomorrow's session. All of you please respond. How many of you are going to give a try? Yes, most of you, right? Yes, great. Okay, so thank you everyone. For the time being, I'm stopping here. We'll meet you all on tomorrow's session at 6 p.m. Okay, thank you everyone.